All right. Hello everyone. So this is going to be a little bit of a different stream. If you're joining us from one of the Microsoft channels, we are doing a 4-hour stream, or we're aiming for about 4 hours. And the idea here is we are going to build an entire game. We're going to try to build a game in Unity, connect it to the cloud, and then do some other fun things. We're also streaming onto my channel, so if you're there, hi. I work as a cloud advocate at Microsoft, and so today we're kind of pairing together and we're doing some cool cloud plus gaming stuff. So hopefully that's interesting and you all want to learn some of that. We've never tried this before on the Microsoft developers side, I don't think. And so this is sort of an experiment. If you like what we're doing, please let me know, because then we can do more of it. If you don't, let me know as well, and then I can stop. But hi, because this is such a longer stream, we're going to try to keep this more casual. So it is longer. If you don't catch all of it, that's totally cool. Please just come in and ask what something that looks interesting is, and we can talk about it. But yeah, that's what we're doing today. So if we go and take a look at this, oops. We're building this. This isn't interesting right now, but it's just a cube that you can fly around. It supports your controller and keyboard. And so the idea here is that is going to be one of the players in our soccer/football space game. So we're going to have 6 of these in total, 5 of them AI controlled with 2 different teams. And then you're going to try to score goals. And that's what we're going to try to build. We're also going to try to hook this up to cloud services, meaning that you should be able to grab things like online high scores, online statistics, like over the course of playing the game, you will get statistics and things like that. Maybe even synchronizing your save data between your PC and your phone if we ever get that far. Keep in mind, total we have about 12 hours to build this, which is not much. That's not a long time to build a game. So we're going to get as far as we can and try to focus more on learning and experimenting with some of this stuff, because I'm learning too. So that's what we're building. So far we have just 3 C# things. I'm going to skip over a lot of the intro to Unity stuff. If you want me to cover some of that, just ask, and we can do that. Otherwise, I'm going to try to skip over a few things and try to move forward, just so we can make some forward progress. But let's cover what we have so far. This is our entire scene. It's just a ship cube. That's a prefab. We're currently using 2D physics. I've built this kind of game before, and while it does work in 3D, it's really hard to do depth perception and actually like play the game in 3D. So we're sticking to 2D. This also means that it translates really well into like a mobile game. So that's what we're working with. We also have 3 components here. We have the input controller, the ship input, which is actually measuring just values, and then the ship controller. So the way this ends up working is the ship input controller or the player input controller is actually sending input data, controller, keyboard input into a ship input, which stores values for how the ship should interact. And then the other thing we have is the ship controller, which reads that ship input and does something with that. So this actually creates a lot of really cool things. I mentioned we were going to have AI in this game eventually. This abstraction means that we can actually pull out this player input controller and replace it with an AI, and everything will still work. So we can have a ship automatically fly just by changing these inputs. And so we can more easily kind of create that AI system. And then ships will still behave exactly the same because they're still using all of the same controls as a player controlled ship. Everything will just work just in a slightly different way. So that's sort of what we're trying to get to with this is we're trying to switch up how all of this works. This is the entirety of what's going on right now. We tried to keep it relatively simple. So we have our ship body, which is just a rigid body 2D, and then that has force and torque applied to it in order to actually physically move it. This means it's actually using physics to turn instead of being arbitrarily turned. And so that's our math. And then it's just using all that inheritance and abstraction pattern to actually pull everything in and do all the fun stuff. So that's that. Let's go and actually start adding some more to this. What we need to do is make this actually a game, because right now it isn't. So first thing I'm going to do is actually just create a cube. Hi, welcome. Welcome to the stream. We're building a game. So let's add a sphere and do this. And so I do not have any art for this game right now. One of the cool things with game development, and especially with like an engine like Unity, is you can actually add art later. And so if you're mindful about how you're actually building what you're doing, you can start swapping those things in. That's sort of how I'm taking this. You might see some art start getting filtered in between these streams over the next 3 days. But that's how this is going to go. This is going to be a 3-part stream. So we're streaming today, and then at the same time tomorrow, Wednesday, and Thursday. So 11 to 3, we're going to kind of be continuing on and finishing whatever it is. So if there's things that you want us to dive into in between that, let me know and we can do that. But let's give this some physics and give it a rigid body. Remember, rigid bodies are required so that this actually moves. If we don't add a rigid body, it's not going to move. We're also going to get rid of the gravity, and I want to double check. I know with 3D physics, Unity gives you a way to actually turn off physics. So if we go into project settings, there's a physics 2D. Yeah, so we're building a space game. So we're just gonna set gravity equal to 0 universally, because I had to scale gravity down to 0 on each of these rigid bodies. But if I just set it globally, there shouldn't be gravity anyway, so it's still not going to fall. And then we can run into it and the ball will move around and bounce. Let's give it some bouncing though. So let's create a ball, I guess. And we're going to give this a fun physics material. Do these work in 2D? It has been a while since I've done 2D stuff. So there it is, physics material 2D. Ball physics material. Let's go and create this, add this to our sphere. And we're going to call this the ball and turn this into a prefab, just so we can reuse it. And now let's make this really interesting, give it like a higher bounce. There's 2 values here. There's the friction and the bounciness, and we can tweak that to do whatever we would like. So yeah, in this case, we want it to be able to bounce a little bit. That'll make it a little bit more exciting, I think. It also means it'll bounce off of the player ships, which might not actually be good. We can tweak that a little bit. There's less, you can do less in 2D than you could with 3D physics, just because of the way it is. But if we hit that now, because it's a bounciness of 1, it receives 100% of that impact force, and then does its thing. So ball. And we also bounce off of that because it's bouncy. So that gives us a way to do this. And you can see it kind of bounces off of the corners and does all other fun things. So hopefully we can turn this into a game. That's the idea. So let's go and tweak this and add a goal as well. And so for the goal, we're going to delete that. And let's go and create an empty game object at some value. There we go. And let's go and give it that setting, and then we can move it into position. So there's a few things that I want this to have. I want this to have a scoring zone, question mark. I don't know what I'm calling this. Oops. And so this is going to be our trigger. So what a trigger is in Unity is a way for you to actually detect that something else has entered that area. So in this case, I want to detect that the ball has gone into the net. And so that's what this trigger is going to do. It's not going to be like a solid wall. Things won't go into it. They'll bounce off, or they won't bounce off of it. They'll be able to go through it, just like a normal thing. And then we can use that as a way to do all of our normal stuff. And so we can tweak this size a little bit. I'll leave that as is for now. I think that's probably good. And then we can mess around with this in just a second. Let's go and assign this. And do that. And then we're just going to finish off the goal like that, I guess. There we go. And so now we have a goal in front of us that we can actually score in. It doesn't actually do anything yet. So we need to actually work a little bit on that. But we can actually hit it through that collider, which means that now we can actually score. And so I'm going to move some things around because this was built really quickly just as like a proof of concept. So let's go and move all of these into the ship. Unity does not care if we move things, so we can just move them. They actually behind the scenes use a reference GUID to actually track all of that and make sure everything works. So that's what we're actually going to use to make sure this is working. And then for this, we're going to have a goal, I guess. We can tweak some of this just to make it work. And I don't know the best way to do this exactly, so we're going to play around a little bit just to make this work. Void on collision enter. Yeah, this should be fine. So we do actually have a few options here. I can do on collision enter, which means it's going to trigger as soon as that ball crosses the line. So any part of that ball crosses the line of the goal. If we want it to be entirely inside the net, we'd have to do this a little bit differently. Either by moving the trigger backwards or by doing something a little cleverer with on collision exit, which let's try that just because I think it'll be more interesting. And so for this, we're going to dive into dot products. So if you don't know what a dot product is the cosine between two vectors. So a vector is any number of things. What a dot product does is take two vectors that are pointing anywhere in space and find an angle, the cosine between them, and we'll let you use that. So you can then use that as a way to detect the angle. It also means that if you're comparing normal vectors, you can actually use that to get either between 1 and -1 and detect what side something is on. So if something is on the positive side, then you're good. And if not, anyway, the point there, We don't even need that. The point of doing this is that we'll actually be able to detect if the ball is going out the bottom or the top of our collider. And so we can actually use that to detect that the ball has fully entered the goal rather than just like slightly cross the line. We can actually tweak that a little bit. So we're going to try to use that as a way to do this. This is just a fun little math thing. Dot products do get easier if you work with only normalized vectors, which means they only have a length of 1. So something to keep in mind. But yeah, there we go. On collision exit 2D. So when it exits, we're going to take the collision, transform position minus the current position. So so this won't quite work because we aren't actually detecting that it is a ball. We're just detecting if anything goes in here and does this. This will give us a difference, which is the actual direction from the collision to that object. We can do a normalized version of that. And then with that normalized version, we can actually compare that to the forward direction of the goal. So if the goal is facing up, I guess is what we'll use. So var dot equals the vector3 dot and then normalized and our transform dot up. We are working in 2D. So forward is actually into the screen in 2D, which is not what we want. We actually want to compare the up vector to the normalized ball direction, so the direction to the ball from the center of our goal. If that is a positive, if the dot product of that is a positive thing, we know that the angle is between 0 and 180. So it is behind the goal. And we can use that to detect scoring. So we can do if dot, I should name that something better. Ball direction is greater than 0. All right, let's just wait for this to think a little bit. All right, so if the ball direction is greater than 0, then we can do something. Let's do that. And then convert things into something useful. So why, that's a float. Why does this think it's comparing a vector 3? Oh, because ball direction is already defined. I got it. Ball to goal angle, question mark? I don't know a good name for this. But all that's doing is just detecting what side of the goal the ball is on. And then we can use that to debug.log scored. So what we're expecting is this ball is going to have to travel entirely through the goal line and then exit it in order to trigger this. And it will only trigger it once because it's an on collision exit. And then we'll use that to detect scoring. So that's the idea. And I think that, yeah, that should be fine. So let's actually attach this to our goal here and see if it works. We're doing some math that I think works. So if we do that, nothing happens. Do I need this to be attached to the scoring zone? Let's find out. Nope. Oops. What have I done? let's go into debugging. So let's just attach to Unity. This is going to actually recompile my project. Unity by default does not build with debugging symbols. But doing this is going to trigger Unity to do this. So it's going to ask me to enable debugging for this session. So if I click yes, now when I run this, where did I put that? There. We should get a breakpoint. We should hit a breakpoint when we touch that line of code. And we can use that to actually detect where we are and what's going on. So let's use that. This is going to have to recompile the project just because of what it's doing. But that will give us debugging symbols. Our game will run slightly slower because of that, which is one of the reasons this isn't done by default. But it will be a handy tool for us to actually check this. There is a way to just always enable this. That was one of the options there. I usually just enable it for a session, just because that's what I do. And so let's run this, see what happens. Well, that's not good. What have I done? Oh, that's why I have on collision exit. That doesn't work. This isn't going to actually detect anything. We want on trigger because we're using triggers. So triggers and collisions are different. A collision will prevent two objects from intersecting. A trigger is fine with that. It's just going to be a trigger. So like a proximity sensor, for example, you can use a trigger to do that. So hopefully we used the wrong thing. This needs to be a collider 2D. So that shouldn't change any of our actual things. I'm just going to rename this so that it actually makes sense with what we're doing. There we go. So now we have this. We'll actually score. We still have a breakpoint. So our game will freeze when we hit that breakpoint. That's how this works. We're actually going to hit that and then we're just going to stop. So if I run forward with this, hopefully we will freeze right there. And so if I actually go back to my game, oh, we're doing this first. You can see the ball to goal angle. The reason we weren't actually, nothing was working is I was using the wrong function. But here you can see the ball to goal angle is actually 1. So what that actually means is that they're directly in line. So the up vector and the ball is actually moving directly up in line with the thing. They're parallel. So because of that, we know that we've scored a goal. The ball will not score if we go in the opposite direction. So if I do something like this, we'll get scored. But if the ball goes in the opposite direction of that goal line, because the dot product will be different, we shouldn't score a goal again. And so that actually will prevent us from, if, for example, somebody is actually hanging out in the net, like here, this, we're actually going to detect ourselves as a goal. But you can see if I come back out, we don't score again. And that's because the dot product detected we were going down and not the other thing. So we got some negative dot product. So we can use this as sort of our way of detecting that. We do need to actually make sure that we're only detecting that for the ball, because otherwise this isn't going to work. But that gives us at least a little bit of help for this. We can actually use that to sort of check things and make sure things are right. So again, if we go too far, everything works. Now what I can do is actually shrink this down. The only important thing with shrinking this is that I have to make sure that it is not too small. Because if the ball moves entirely over in one frame, if it moves entirely through this collider or this trigger, we won't actually detect it. I don't think that should be a problem. But we can tweak this so we can make this much thinner and actually just move it down like 4 point 5 there. So that's like right. I don't have a gizmo on this. But that's right there. What I'm going to do actually, because we're doing this, is we're going to add a gizmo to this. How do I want to do this? Because we don't actually have our goal. Let's draw a gizmos.color. So the way the gizmos function works, hi, welcome. We're building a game. So what the way this gizmos function works is inside of Unity's editor, it's going to actually draw helpers. So you can see we had that green outline for a collider inside of Unity. This lets us define our own. So anything that has this script attached to it is going to have its own detector. What I'm going to do is actually give this an arrow. Maybe handles would work better. Draw arrow. I thought there was an arrow in here, but maybe not. This is fine. So we'll do color dot, I don't know, a good cyan. Sure. Hi, welcome. So yeah, so we're going to just do a cyan thing, and I'm just going to make an arrow. Gizmos.draw line from this dot transform dot position to this dot transform dot position plus transform dot forward. And then I'm actually going to save this. Target direction position. And we're going to use this instead. And then I can actually use this to draw the arrow bits. So we can actually gizmos dot draw line. And let's do a transform dot forward. Whoa. Divided by 2. I'm just making this up. This is entirely just so that it's easier for us to understand what this is actually doing. And is there a back? No. Okay. So you have forward, up, and right. So negative is actually backwards. That's what we're doing. We're moving backwards through space to create this. And then I also want to move this to the right and to the left. So let's save this now. Var arrow ends start. Sure. And these are all just things that I'm creating just so that I don't have to redo math. And then we'll do minus this dot transform dot forward divided by 2. Not forward, sorry, right divided by 2. How long have I been scripting for? That is a great question. I don't know. Probably about 15 or so years, I would say. Now, keep in mind, most of that is just blind tinkering, like no direction, no training or school or anything. Just trying to like find tools and see what works. I got started using a tool that doesn't exist anymore, and then moved into Game Maker, which some of people might still be familiar with. I used an older version, and then that was all a visual scripting language. So you would actually click and drag like elements together to write your code. And then from there, started writing GML, which is their scripting language. And then moved into Unity and started writing JavaScript in Unity. That isn't supported anymore. And then decided to learn C#, and mostly because I was working with the Zune at the time. I worked on weird things. So working on the Zune only supported XNA, and so you had to use .NET. It was like .NET Framework 3 or something like that. And so I had to learn .NET, and then I took that into Unity and now do this. So that's how I got here. There's a lot more tools now and a lot more resources for getting started. If you're just trying to get started with gaming, there are lots of options available to you. Unity is a great one. Other ones are like Godot or Unreal, or even Game Maker is still around and still really useful. The trick when you're getting started is not figuring out how to write the best code. It's not figuring out how to build your dream game. The trick is figuring out how to turn what's in here, what's in your brain, into something on paper that you can actually like do. That's the hardest part of any engineering thing, is figuring out how to translate your thoughts and communicate them into a language that the computer speaks. And that doesn't matter what language you learn, because once you learn that part of it, you can take that anywhere. You can learn any language you want, and do whatever you want with it. So if you're trying to get started, that's where I would start. That's not something that you're going to actively practice. You can't like practice that. But what you can do is just build things. So if games get you excited and you really like building games, find a game engine that you like using. It doesn't have to be something that will like has the highest fidelity graphics or anything. Just find something that's fun, and then do that. Be realistic. In chat, somebody's calling out, don't just go and make out like, you're not going to build an MMO the first time you start doing this. You're not going to build an RPG the first time you start doing this. You're not going to remake like your favorite game. That it just games take a lot of work. Like we have 12 hours here and we're barely going to get things done. So be realistic about your goals. And that doesn't mean like don't try it. Do try it, but try to break things down into like small steps. Instead of saying I want to build an MMO, what about a quest system? Or what about a world economy? Or whatever sounds interesting that day or that week. When I started my channel on YouTube, the goal there was I just want to build something every week. I just want to start doing things and start learning things and do a different thing, so that I can learn different things. That's something that's really, really helpful because you get exposed to so many different things. And if you're in software, it's going to change. It's going to be different than it is right now. Especially if you're just going into school, what it looks like now versus what it will look like 4 or 5 years when you get out of school, it's going to be different. I don't know what it's going to look like, but it's going to be different. And so figuring out how to actually learn things is one of the best skills you can have. So yeah, anyway, we built an arrow. I think this will work. I used forward. Let's go. And how many days am I doing? So this is going to be 3 days. So today, tomorrow, and Thursday, we are going to be doing 4 hours each. So if you want, come back. If you don't, there will be VODs available on the channel, so you can go and watch those instead. Or if you show up and can't, yeah, so this is part 1, we're just getting started. If you miss a day or miss parts of a day or whatever, just come in and ask questions in chat and we can go on tangents and help. If this is really interesting and people really like it, and we don't finish everything that I would like to get done by the end of the 3rd day, we can keep going into the new year and keep doing more stuff like this. But this is really just an experiment to see if this is content that people like. So yeah, that's what this is. But yeah, anyway, I need to swap out all these transform.forwards with ups, because we're in 2D again. And so I used the wrong thing. Cool. So hopefully now our arrow points up. There we go. So that gives us a way of figuring out where our goal actually is. So you can actually detect. So we actually know which way our goal is facing, because that means I can put it down here too. Oops, that's new. Let's do this, and then move it down. And now this is me just tinkering with things, but we're going to rotate this 180 degrees around the wrong axis. So the cool thing with this being a 2D game is that forward is into the screen. So the Z axis is that blue one going into the screen. If we want to rotate objects, rotation in 2D becomes a little bit easier than 3D. We can just plug this into Z and get the rotation we want. And then for this, we can just move these down. And now we have two goals that hopefully give us a way to actually score. Let's move our camera down a little bit so we can do that. Maybe zoom it out a little bit, but this will be fine for now. And so, yeah, there we go. There's that. And so we can score once, and then if I go down through the bottom, we score again because we still detect our ship. But then coming back into the game, we do not, because it's still detecting the proper rotation. And what that just tested was that actually reorienting things correctly fixes things. It actually makes things work a little bit. It means that I can rotate this, and it's not always just up in the game. It's based off of the rotation of our goal. So we can actually rely on these arrows that I created to actually tell us which direction our goal is facing and which way you can score from. So things going in the direction of the arrow will score. Yeah. I think that's it. This is a very small play area for this right now. We're still figuring this out. We might want to do some like dynamic camera stuff as well in this, just so that the camera actually follows the player around a little bit, because right now it doesn't. But first, let's make our game actually work. We have a ball, and that can go through and trigger scoring, but our player ships can go through. So yeah, awesome. Cool. Welcome. Glad you're here. We're going to be here all week, basically. So it's going to be fun. So in this case, what we have is two goals. They just detect any object going through them. There's lots of ways to figure out the best way, I guess, what something is. We could tag this. So we have our ball here. What we could do is tag this if we wanted to. That would probably work. I don't know if that's what I like doing. One of the nice things of what we are doing is we're building a really small game, which means things don't need to be optimized. And if you're just getting started, you don't need to worry usually about making the most optimal thing. You will do that one thing that has like a n factorial time complexity, and then you might need to fix that. But figuring out things that are doing things that are a little bit slow, but are something that you know how to do, will get you moving forward. That can be a little bit more useful. And then you can come back if it becomes a problem. So that's what we're going to do here. Is we are actually going to have something that controls our ball. Let's create two things, I think. A ball and a game controllers script. And what I'm going to do is create a _game controller. And the underscore is not there for any reason other than it makes it easier for me to find it in my thing. That's the only reason. It's just what I do. And so that's going to be something where we can store a game state. So let's go and add. I don't want to call this the game controller. Let's call this the game ball controller. And then the game score controller. And so these objects that I'm creating right now, they're going to exist for the entire time that this scene is loaded. And so I'm going to use them as a reference for things like scoring. So we're going to have two different teams. Don't know the colors, but we're going to have like team 1 and team 2. This will be able to track scores, and it will also be able to track, is the ball in play? If not, maybe we should respawn it. So that's what's going to happen there. I don't know if we're going to have like I don't know sports. I don't know if we're going to have like a kickoff or anything like that. The ball might just respawn after a set period of time after you've scored. We can tweak that and kind of figure things out. One of the really cool things with like this style of development where you can just click play and get into your game is you can iterate on whatever it is until it's fun. And that's the most important thing, not that it fulfills some technical spec requirements, but just that you're building something that's fun. Whether that's fun for you or fun for whoever's playing it, but might be up to you. But that's for me, that's what I try to build for, as finding something that's really fun that you can share with other people. So that's what we're going to try to do. We're going to add both of these to our game controller. And we'll do the score in just a bit. So what we're going to do with the score is actually assign teams to the goal. And so if you score, it gives the point to the other team. So that way you can actually handle points. We'll probably want to do some extra detection. So for example, figuring out who scored what goal. We might want to figure that out. I don't quite know how we're going to do that yet, but we'll figure it out. So we have our game ball controller. This is actually going to handle the game ball. So public float ball respawn delay. So I'm going to give like a 3 second, we can tweak this later, respawn delay. The idea here is after you score, I don't want the ball to just immediately respawn back at the start, because then that encourages players to camp it. If like they know the ball is going in, just turn around and grab the ball and then just score the opposite way. Instead, what we can do is we can give it a little bit of a delay so that people can reposition and get back to where they need to be. And then it will spawn in. So let's do private float ball respawn, and we'll do that. And so let's also do a public game object with our game ball prefab public transform for our ball spawn location. So this is just going to be a point in space where we spawn the ball back. So we can use that to recreate the ball. Public game object. All right, getting a little bit ahead of myself, but that's okay. So we have our game ball. We have the spawn, respawn delay. So that's tracking the prefab to respawn it, but we also should track the private that in play ball. I need to create this. So I created a space ball controller, which doesn't exist. And that's just going to be attached to the ball that you're playing with. And that way we can actually handle the logic attached to the ball. This will be useful for example, tracking players that actually interact with the ball. So we can actually do a void on collision. Enter 2D. Track players that hit the ball to detect who scored the point. And so we can use that function, I think, to create a list of the people who have interacted with the ball. And that will give us a way to actually track things like goals, but also potentially things like assists. So if somebody hits it and then a second later somebody else hits it, that could be an assist. I don't know if we have time to actually do all of that, but that's something that I'm thinking about. Here, I think we can just leave everything else. Yeah, well, this doesn't need anything right now. And then ship controller, that's not any of what I want. All right, let's go into the game controllers again, find the ball controller, and now we can actually implement all of this. So we can actually make this do everything we need it to. So if in play ball is null, so if there is no current ball in play, we need to go and find one. So find object of type that like so. And so this is just going to search the entire scene for something that matches that type. This function is really slow because it's doing a full search over your entire scene. Not great if you have lots of things. We could keep a reference or something else, but in this case, I think it's fine because we shouldn't ever run into this, I don't think. We'll find out. If it's still null, we should do something. Something like this. This might not be the best way to do this because our cyclomatic complexity, which is the brackets, I guess, is how you can do that. So this is not great, but it's a thing. And so all I'm doing is saying find it if it exists. Otherwise, if it doesn't. But we have a response, so this might not be good either. I don't know how I want to do this. We'll figure this out. Well, that's clever. Using the null continuation. Yeah, I like that. Okay. So we had a suggestion from chat to do if it equals itself, or the double question mark there is I think it's a null continuation. And so what that does is actually detect if the left-hand side is null. So in this case, if play ball is null, then you assign it to the right, then use the right-hand side, evaluate the right-hand side. Otherwise, if it's not null, then just return the left-hand side without doing the right-hand side. So this will avoid doing this, and it shrinks down all of those if statements and removes the cyclomatic complexity that I was concerned about. That's a really good idea. So we have that. The only downside with this option is that it is going to run this check every frame while the ball is respawning. And I don't know if I want that. So if ball respawn is greater than 0 or is less than or equal to 0, let's do this. So we're going to have to come back and clean this up. My recommendation as far as keeping, like, refactoring code and making it nice, you don't need to make it look nice the first time you do that. Just like getting your thoughts out can be really helpful because it can help you think out and like complete thoughts, and then you can come back and sort it out later. So we're kind of building some sort of state machine here by having if the ball is in respawning or not. I always write my code perfect the first time, promise. Yeah, I'm sure. So what we're doing is, this is a state machine. Audio quality is different on this channel. Is it better? Or oh no, I don't know if there's audio issues. If there are, let me know and I can try to fix them. This is in a few different places, so I can tinker with it. But I can, yeah, try to figure it out. We still have a few hours, so getting that good would be good. Yeah. Let's see here. If the ball respawn is less than or equal to 0, so let's leave some comments so we help ourselves out a little bit. So state. Ball is in play, or should be. Have no problems with audio. Okay, cool. We'll trust that it's good. Let me just double check that everything. Yeah, everything seems fine. Interesting. It's not. So ball respawn doesn't feel obvious. Can you create a prop for it? That's smart. So creating a property to kind of track these. I think I might. I don't know. This is probably going to turn into a switch statement at some point and have separate functions for both of these. So this update function, I'm going to hopefully finish it here and then break it apart again and move everything back out into things that are smaller and make a little bit more sense. I think that's what I'm thinking. But yeah, I think I was leaning towards enum as far as how this is going to go, but I don't actually know. We'll figure that out as we get there. An enum for just 2 states might not be necessary, but who knows? So if all respawn is less than or equal to 0, find it. Otherwise, if the in-play ball is still null, so if we searched for the ball and it did not do that, then start our ball respawn equal to the respawn delay. Start game ball. So if for any reason we like delete the game ball, or it ends up out of something, we can do that. I have not tried GitHub Copilot. That has not been something. There's some smarts in Visual Studio now, and I've just been using that. My personal preference with coding is usually I prefer not less automation over more automation. Because usually I know what I want to type and just really slow at typing it. And so for me, it's not so much I need something to complete things as much as just doing things. But if it helps you, absolutely go ahead. I think those kind of tools are super cool. It's just not something that fits into my preferred workflow. So at least not in the trials that I've had. So we have this. That'll trigger our ball respawn. Perfect. Otherwise, yeah, I think that's a good point. Just reading your code is probably a good thing. There are people who just will copy, and I don't. Copying code from some place like Stack Overflow or from even a tutorial, like that's what I do. Is make and share code samples with people, and there's plenty of people who have taken code from some of my videos and used it. That's great. But a lot of times when I'm sharing code, I intentionally only share parts of it, and that's because I want people to think a little bit about how it's supposed to work and also how it's supposed to work in their solution. A lot of software, there's lots of different ways to solve problems, and the correct way to solve it is going to be very dependent on what you're actually trying to solve for. And so that means that you can choose all of these different options, and there might be somebody who has done that before, but their solution might be optimizing for something that you did not want to optimize for. And you wanted this benefit instead. That can be something that's really hard to figure out. Even when I'm like looking at code samples or something like that, because I do the same thing, I try to write them out again, and slowly like think about them and then change things slowly. So like swap out one value here and see what that does, and then use that as a way to learn things. So that's usually how I learn. And especially now, if you're working in like cloud, there's things like containers where you can create an entire infrastructure, build an entire cloud system with your website and your database and your monitoring and everything else. And you can do that in like minutes. And then you can tinker around with it and tweak settings and do all these other things. And then if it doesn't work, you can just roll it back and undo the thing in Git or whatever. And that's a really handy way to like learn things. Git is less friendly inside of like a game engine like Unity. It doesn't quite handle large assets like textures and music and things like that as nicely, but it can still lean into that workflow. So yeah, hopefully that's helpful. I treat it as a total black box is Docker files. Same with Kubernetes pods. So that's actually, my background is mostly in that sort of environment. So Docker and Kubernetes and sort of like the cloud native infrastructure. That's sort of where I really like leaning, because it's open source and it's accessible almost wherever you want to take it. Like if we want, like I can go and I think I stopped Docker Desktop for this. So we're going to get this. But you can run it locally. You don't need to pay a cloud provider or do anything like that. You don't even need an internet connection if you want to just work on Docker stuff and have it pulled in. And then, yeah, can't configure it from scratch. So if you're interested in that, there's some really, especially if you have like a gaming background, there's a really cool, this is a tangent. We're going to go on lots of these, I imagine. But there's a really cool Docker thing that I really like working with. that teaches you lots about Docker and like hosting your own servers and things like that from Docker, but it's for Minecraft. So you can host a Minecraft server with this and just create a new Docker container to host a Minecraft server. What you can do instead of this, though, is instead of just using this image, try to create a Docker file, use this as the base image, and then pull in some other mods or something, some other like custom settings or data packs or something, and use that to kind of tweak what you're doing. That could be a really fun way to learn and tinker and experiment with things. The cool thing with Docker is, can I paste the link? Sure. Let me just grab this. And this is in Twitch. There we go. So there is that. Did that not work? Hold on. Yeah. Well, I can fix that. Here you go. So you can use that and kind of tinker with it and explore. And that's sort of how I recommend learning all things. It doesn't really have to be games. It doesn't have to be cloud stuff. You just want to learn like how to build a desktop app, because it'd be really handy if you could like import, I don't know, something and tinker with it. That tinkering, even if what you do doesn't actually work. Okay. Yeah, I'll take a look at those between streams and try to get any issues fixed before the next one. But yeah, tinkering is a good way to learn. It's a fun way to experiment with new things. And especially with Docker, like you're not messing up your own machine. So it's not like when you used to create like a database or something, you'd create one database for your entire computer basically. And you'd host like an Apache server directly from like Windows. The cool thing with Docker is that doesn't have to happen anymore. And so if it doesn't work, you can just get rid of it and try it again. And that's really fun. Cool. Interested with modding an old text-based multiplayer game in C. That sounds fun. Let me know how that goes. And it's gone downhill ever since. Nice. So tangents aside, let's actually make this respawn our ball. So what we're going to do is do ball respawn minus equal this. Oh, this isn't gonna work. Actually, it will. It'll be fine. Time.delta time. So if you're new to Unity, the delta time is the time that has elapsed since the last frame. So what that means is that we're not just subtracting a set value. If the frame rate changes or something else happens, the delta time is actually going to make sure everything just works. And so that you have a consistent experience regardless of how fast a computer is. Otherwise, things will behave significantly different. You can see that if you like unlock old games, which were programmed to run at a specific like 30 frames per second and then run them at 500, suddenly they go really fast. We don't want that. So that's what this is for. It's just going to count down that ball respawn time. And then when it gets below 0, so if ball respawn is less than 0, we do need to include this here. Less than or equal to 0. So if this is less than or equal to 0, then we're going to respawn this. I'm actually going to take the suggestion from chat and turn this into a property. So private is ball in play. Cool. Is ball in play. And we're going to create just a getter property that evaluates this instead, so that we have consistent checks between these two spaces, because if they aren't consistent, our game will break. Probably unlikely, but it could break. So is ball in play. And then this will check, is the ball in play? It is. If it is, the ball doesn't exist, so we need to create one. So what we're going to do is do our so var created ball equals so creating things is done with instantiate, so that's what we're going to use, and we're going to create a ball prefab. What did I call this? The game ball. Cool. And then we have our transform somewhere. The ball spawn location, that was it. And that needs to be our location, position, sorry. And we can use just a identity quaternion. Where, as much as we can, we're not going to touch quaternions at all in this because I don't want to. That's the entire goal. Quaternions are a 4-dimensional vector that are used for handling rotations. They're also really complicated. I don't know how they work, so we're gonna just kind of ignore that. If you do want to know how, or if you do want to work with them, don't try to manually work with quaternions. Use the helper functions, because it will make things a lot easier. So you can create things from like Euler angles, or from whatever else, or multiply them together to add two angles together. But just, yeah, working with them manually is complicated, and I don't understand it. Yeah, so that's the idea. Is it does remove gimbal locking. There's lots of interesting things. There was there's actually really good diagrams of this on Wikipedia of all places. Wish you knew more. So let's talk about gimbal locking, because why not? Do I have anything that's a circle on my desk? Not really. Here, let's do this. Random desk toys. So this is a sphere. But what you can picture is you have 3 different axes. You have your X, Y, and Z axes, and these are like concentric circles inside of one another. So a ring inside of a ring inside of another ring at 90-degree angles to each other. And the issue you can run into is if you want to do any rotation by just measuring the X, Y, and Z rotations, what that turns into is you're just rotating one of those rings inside of that instance. But what that means is that since the rings rotated now, they're no longer in line with one another. So if you actually want to rotate some other way, it's not going to have the same effect. What that means is that you'll notice this in like first-person shooter games. For example, if you look up at the sky, the same movement of your mouse to rotate you 180 degrees is the same whether you're looking up versus looking directly ahead, even though the total distance your cursor is moving in space is significantly less, because your cursor is just spinning around a single point in space, versus like all the way across your screen horizontally. However, because you're rotating in the XYZ instead of using quaternions, you'll get this. This is one of the reasons why we're not doing this in 3D, because if we did, everything we did would be quaternions. So that's what we're trying to avoid. But yeah, this gives us a way to actually spawn in our ball. I think that should work. And actually, when we start, Oh, this will all work, I think. No worries. Part of the goal of like these kind of like longer streams is that we get to talk about what you all want to talk about. So if there's something interesting or you like I do something really quickly and you want to know more about that, let's talk about it. Or if we end up going in different ways. Like the goal of this is eventually to start adding cloud components so we can log in, track high scores, have like online stats and stuff for your player. That's where we're headed. So all of this kind of works. So if you're looking for stuff that I'm doing, check out either you're on the Microsoft Developer Twitch, so you can find me there. I do it's called the Code Lab every weekday, or sorry, every Tuesday at 4 usually. Not this Tuesday, just because we're doing this instead. But usually we do that as just a way to kind of build things. In the new year, we're starting as something where we're building a Blazor website. Otherwise, you can find me on the Microsoft Reactor YouTube, or you can find me on World of Zero on YouTube, which is my personal channel. So there's a lot of stuff about Unity and things like that there, depending on what you're looking for. So there's all of those. Yep, that's the one. So I spent, when we're talking about streaming, I spent like 2 years wanting to stream. Yeah, on YouTube. I do have a Twitch, but I do not use Twitch much anymore. So at least I found more people at least watch on YouTube there. So that's where that is. As far as streaming goes, if you're tempted and want to try it, just starting is probably the hardest part of it. Like figuring out how to talk to a camera and how to like maintain a conversation when nobody is there is really hard. So one of the, like, if you're just getting started, try things. Like I was just streaming random like game dev stuff. And then it turned into my full-time job. That's how I got this job. It's at least one of the big contributors to getting this job was actually just streaming and building content and doing things like that, whether it's blogging or doing things or whatever. For me, I like doing this kind of content, but I like doing it in recorded videos. So like 30 minutes, 20 minutes, whatever. And doing like a live coding, we're going to build this ball controller and do it live, but I'm going to record it. And that way I can have a little bit more control over it and kind of do it at my own pace. And there's less pressure of things happening when that works. I also find like there are so many people in chat just suggesting things and talking and doing all those different things. Plus you learn so much from just re-watching yourself solve problems live. Like I've been doing this for about 6 or 7 years now. And so over time you start realizing like, I really like doing this thing, or I try to do this when I run into these problems, or like, I don't know how to explain these. And so it makes you better at communicating with like your team, which is really good as like a engineer. Communication is our job. So actually talking to people and making sure that they actually know what's going on, that's as much of a job as like the programming bit. And plus it also like you get to share really cool things, plus you get to learn really cool things. So I think it's really cool. Just take some time when you're figuring it out. Don't expect an audience at first. If you're on Twitch, if you're intending to stream to Twitch, just start talking. Just talk to yourself. If you don't like doing that, put like googly eyes on your camera and talk to that. It can be really fun. So yeah, and then don't stress out too much if like that doesn't, if it doesn't turn out well like the first few times, that's fine. Go back and watch some of like your biggest streamers from like their first few streams, and you'll realize everybody starts somewhere. And it's not just you. That's just how it is. So it'll take a little bit for you to kind of figure out what you like doing and what you don't like doing, and then you can just kind of lean into those things and then just like change one thing every stream, and you'll figure things out. Anyway, let's go and refactor this a little bit, just to make this a little bit nicer. So let's go and pull these out into methods. So update ball in play, and this will be our, oh, the plushie on top of the lens is smart too. Yeah, I like that one. I've always just put like just those cheap plastic googly eyes and just put it on either side of the lens. It makes it so much easier for you to actually stare at a camera that doesn't like, it is just a camera, especially if nobody's there chatting. Especially with like software stuff, it's pretty common for people to like lurk and pull up a software stream while they're doing their own coding or doing something else. So they're not always going to be active in your chat. So being able to just like hold a conversation yourself and talk about what you're doing is fine. If you're just getting started, my recommendation is also turn off like the viewership numbers and don't pay attention to that necessarily the first few times. You can look at it afterwards. But it can just be stressful if you're streaming for an hour and that number is like 0 or 1 or 2 for the entire hour. It can be a lot more fun if you just enjoy the process of streaming and doing that thing. And then it will grow over time as you get more comfortable and do all of that. So let's see, update. Okay, so we just refactored this to make it a little bit cleaner. So now it's just if the ball's in play, update this, and then otherwise just do the respawn. So now they have their own separate updates, and we can do all these. So yeah, it's super fun. Yeah, I think that should be everything we need to actually get our ball respawning. So what I'm going to do now is actually create a ball respawn location. Let's go ahead and drop this there. Oops. So I'm just putting that at the center of the screen. And so we can actually respawn this. Update ball in play, update ball respawn. Subtracts that. Okay. I would like a countdown for this so that as the ball is coming into play, we have a countdown for when it's actually going to respawn. So the players all know that the ball is about to respawn. So what we can do is count this down. How do I want to do this? Let's do a... Let's see. Var respawn is equal to math dot floor ceiling. I don't know what I'm doing here. What I'm trying to do is see if we've passed the specific point. So I'm going to take the ball respawn, take the ceiling of it, subtract our time, and then take the ceiling again. Our respawn. So something like this. So if the respawn is not equal to math dot ceiling of the ball respawn. So ceiling rounds up to the highest value above wherever we are. Does anybody know here what we're doing? We're building a game. So what we're trying to do is build a space soccer or space football, depending on where in the world you live. We'll get to that in just a second, but we have scoring. I will talk about how all of this works very quickly. Uh, oh, got it. Okay. Missing things in chat. So, let's do a interpolated string. If you do this $ in front of do this, then we can do this, and let's just throw in a respawn. Oh, I don't know what I'm doing. mathf.ceiling all respawn, something like that. So the $ in front of a string in C# is an interpolated string. What that means is that you can insert code and things inside of curly brackets inside of your strings. So you don't need to use a format string anymore. Just makes it a little bit easier for you to actually create things. Why? Oh, semicolons. Those are important. So what this should do, if I've done this correctly, is give us a countdown just in our debug statements. We can move this into a chat message or something later, but it gives us a way to track what's going on. Yeah, I think that's accurate. Coding is largely problem solving. People will have different issues or things that you need to do, and figuring out how to solve them in the way that actually fits whatever it is. There's always lots of options when you're coding to solve a problem. If somebody else wanted to build this game, they would probably do it entirely differently, and that's okay. So it's just problem solving and communication, I think, are the two parts, because it's not just being able to solve the problem, it's being able to actually communicate that problem to the computer and to yourself and the rest of your team really clearly. Especially in like bigger projects and bigger teams, that becomes really important, because you won't be the only person working on that. And so being able to write something that other people can take and learn and understand is really, really hard, especially if they're coming in 5-10 years later and trying to understand what you did now. That can be really difficult. So I think I've created something that'll work. Let's find out. Let's create a ball controller and apply this. So that applies it to the prefab. And then I'm going to delete it. And then we can move down, I think. And then we can run this and see what happens. If all of this works. Oh, okay. I didn't assign anything. So we're stuck in a loop of it being broken. But we had a thing. So we had a countdown during all of this, and it's trying to create a ball that doesn't exist because I didn't assign it. But if we do, I think everything will work. So we can actually go into our ball, assign that here, and then give it the ball respawn location as our transform. So now I actually have a place to spawn this in and make sure everything is working. And then we can try and see what happens. So we had the countdown, so that was working. Hello, welcome to the stream. So countdown, 3, 2, 1, 0. And it worked. Okay, so now if I score, it will work, and I can re-trigger this by just deleting this, and we'll get 2, 1, 0, and it respawns again. Uh-oh. That's not good. Right, I'm going to need to fix that. Okay, so okay, we need to do something to fix whatever that was. We were respawning more and more and more of these game balls. We only want one, And by the end of that, I had spawned like 8. That's not great. So we're gonna need to fix that. Let's go and fix that by doing in-play ball equals the ball we just created. Let's go and get the controller from it so we can actually use that as a way to update the reference. Update ball respawn. And then that should hopefully work? Question mark. We'll see what happens. But the idea here is that we can actually count down, so 3, 2, 1, and then spawn it. And then if I delete this caused the issue last time. So it detects that it's not there and then respawns it. And I think everything's good now, because we only count once and then respawn it, which means that now when I score, I can just destroy the ball that scored, replace it with some like goal explosion or something like that, and we have our thing that works. So inside of our goal now, we have our detect goal scoring thing. And so if the ball scored, we can destroy the collider.game object and use that to just kind of delete the ball. So what this means now is that I can score a point and then the ball should respawn. We don't do scoring yet, but that can come right after this. So it's going to spawn in. So 3, 2, 1. And then we can score. Done. Score 2, 1, 0. Done. And then we can just keep playing that way. So now we have like a game loop, sort of. And we can use that as our way of moving everything forward. So that's that. Now we just need to make this a little bit more complicated. So in this case, we can score. We need to actually give points to a team. So that's where this score controller comes in. I think before I do that, we haven't done any art yet, so we're gonna quickly create a goal explosion. And that will just be our celebration for scoring. And for this, I'm actually going to assign it to the ball, I guess. And so if you're new to Unity, particles are large numbers of 3D objects that you can use. We're creating a 2D game, but Unity is a 3D engine, so there's no reason we can't go and create something in 3D. So everything in this game is actually 3D objects. You can use sprites and things like that. That all works still. But in this case, we're just going to create it with particles because I think that'll work. And so let's just create something really fun really quickly. Let's go and create a sphere. That will make everything go out in different directions. I think actually circle might be better. And the only reason circle is because then you don't get things coming at the camera. This will only do it around the edge of the circle. And it's a 2D thing, so that just seems like it makes sense. And then we can shrink it down so it has a size of 0. And we're also going to reduce the emissions. So the rate over time is just 0. And instead, we're going to do a burst of 30, like that. Over, is this how this works? I think so. Let's slow that down just a little bit. So like 3, Nope. Not doing what I thought. So rate over time. There's a lifetime. Let's take this and set this to like 1. We'll set it to 0, I think. And then we can play with this a little bit just to make it fun. What I like to do is just kind of tweak things like the starting speed and move it between 2 constants so everything isn't moving at the same speed. So like between 1 and 5. That didn't work. Oh, that's why. And so we end up with something like that. And we can make this look nicer. One of my hopes is that I can add some art stuff in between these streams. I am not a graphics person. Not something I know anything about. So don't know how to do that. Hello, welcome to the stream. So we'll probably do that in between streams just so that I don't end up like opening up Blender or something like that and tinkering with it for hours and not getting anything done. Instead, we're going to just work on this and try to get at least some approximation, get some of the effects in and some of those, and then we can actually go back in and do all of this. Like everything we're doing is just boxes. And then we can make it look nice later. Because everything is prefabs, I can just drop art assets into any of this stuff and it will replace every reference to it in the game, which means we can do that at any time. As long as we're using prefabs, there's no reason why we can't just go back in and add art and things later. We don't need to do that right now. So there's our emission stuff. Rate over time, that's fine. The lifetime is how long that explosion is going to last. So we can set it to like 3, I think. And let's make this way more exciting. Let's go up to like 200. There we go. And set the speed to like 0.1. Bang. It's a really big explosion. And then we can, let's see here. Change things like the color over the lifetime. So the lifetime is how long this effect is going to last. I set it to 5 seconds. So over the course of that, we have sort of a sliding scale between 1 and 0, representing how long it's been in our scene. And we can use that to actually tweak things like the color and the opacity. So I can just drag the alpha down and things will fade out over time. And then I can change this curve so that things will be mostly opaque until the second half and then they'll fade out. And we can do this to do other things like change the color or whatever. But it gives us a way to tweak that a little bit. The other thing I'm going to do is pick a few different colors to make this more fun. And then we get that. Now, this isn't intended to look great. It's just a bunch of circles, but that's okay. We can make this look better by adding actual art to it later. And that will actually make a whole bunch of difference. Right now, though, it just gets the point across, and it gives us a way to actually use this in our game before actually doing anything. The only other thing I want to detect is there's this part I haven't used in a while, so I don't actually know where this is anymore. There's a way to stop this from repeating. There's the loop. So that will mean that it won't just keep repeating. It will only play once, because it's really weird for something to keep exploding. It's set to play on awake, so it's going to play immediately as soon as it spawns. And then we just need to detect when it's done and remove it, which we can do in a script. So I think that's good. Let's test it and see what happens. So let's do goal explosions. let's just drop this into there. So we have a reference to it, and then we can grab our ball, which is no longer a thing. It's only stored in a prefab. It's not actually in our scene at all. So we can actually use this to grab a reference to the ball and then do some other fun things. Like this. So I believe there's a private void on destroy. And so we're just going to use this to spawn the goal explosion at ourselves. So this .transform .position, and we'll just use our own rotation. The identity rotation is always going to be at 0, 0, 0, so no rotation. This transform rotation, theoretically our ball could rotate if we want it to. I don't know if there's ever any reason why that would change things, but it gives us a way to add some extra stuff to this. So I'm going to do it. Public game object. Let's do this. Our goal explosion goes in there. Let's do a header. I think that's what that's called. This isn't the right place for this. I'm realizing that now. I've named things poorly. We want to be here. So let me just delete that and move it over here into our correctly labeled thing, which means we probably don't need that header anymore. Just to show what that does, the header is actually going to add a delimiter inside of the Unity inspector, which is that thing over here, that actually gives it a title. So you can use that to actually, if you have lots of settings, you can use that to create a delimiter between them, so that things mean different things and are separated. We just have the one now, so it is just taking up space, but it can make things a little bit nicer when you're actually working with it. Anyway, so there's our goal explosion assigned there, and that should automatically spawn every time we score. And I think that's that. So let's test it. We assigned the goal explosion inside the prefab, so every instance that we spawn should have it. So let's actually try this. Boom. And so we can score, and it only plays once. The only downside is that explosion is staying around. So it's not going away. We've just created this thing to spawn it, and now it's just there forever. And that's not what we want necessarily. Ideally, we would like to get rid of it. So that's what I'm going to do inside of here, I guess. Other. That's a really bad name for a directory. So let's go and create a timed despawn. There's lots of ways to do this. I am not going to do it using coroutines, which I think is probably the preferred way to do this. But I'm just going to go and assign it. So let's lock that, switch over to our timed thing. And what this is just going to do is create a timer that just counts down. So a public float timer, and we'll set that equal to like some default of like 10. And then we don't need a start. And then update is just going to count down. So timer minus equals time. And then if the timer falls below 0, then destroy it. Really important when you're using destroy to destroy the game object and not this. This is a reference to the mono behavior, which would just mean this script would go away. We want to get rid of the game object that this is attached to. So something that I screw up all the time, just make sure that you do the game object. And then all that's going to do is just give us a way to delete things over time so we can keep things slightly cleaner. There's better ways to do this, like instance pools and things, so that we can reuse assets without having to recreate them. It turns out creating objects is actually relatively slow. And so if you have like a game that uses lots of something like thousands and thousands of coins or something like that, you don't want to recreate a coin every time you need one. Instead, you might just create a pool that has 200 or so, however many are going to be the maximum on screen at one time. Your pool would store those and then just reuse them as needed throughout the scene and just kind of move those instances around. So you don't have to keep creating and destroying things, because both of those are more expensive tasks. Again, we have cubes on the screen, so that isn't really that big of a concern here. We're just going to focus on writing things fast. So if we go back to our goal explosion, we can set it to 10. I think our life was set to 5, so let's set this like 6. And so if we run this now, that goal should despawn after it spawns. So we have the goal explosion set 2, 1, 0, and then it cleans itself up. So we no longer have that reference just kind of hanging out, and we can work on that. So that gives us a way to do all of that. The other thing, we now have something attached to our ball. Do I? Okay, weird. Interesting. We have something attached to our ball. So if we go to our goal now, we have this tool that detects balls. If is game ball ? That is a clever name. I like that. We'll create more of you, don't worry. So if is game ball of the collider dot game object. Let's do this. And so what I was going to do is do this and create a is game ball test here. I mentioned earlier in the stream about cyclomatic complexity, which is measuring how deep, so off to the right hand side of your screen, your code is. So basically the number of tabs or conditions and branches throughout your code. Ideally, you want to keep that number low. It's not like a hard rule. It just makes things easier to understand if you don't have to keep in mind all the different conditions and branches throughout your code as you're considering a function. So instead, what we can do is put a not here. So if it's not the game ball, then we can return here and do nothing, and everything else. So only work on the game ball. And so this actually makes sure that we're doing that, but it prevents us from actually adding that tab indentation, which just kind of helps keep our code a little bit cleaner. So there's all of that. We just need to actually implement this, which is just a quick check. And we're going to return .get, and we're going to get the I called it the Spaceball controller. That was a interesting choice, but we'll create that and say if it's not null. Yeah. Right. it knows what I want. So if it's not null, then it is the game ball, and we can use that and detect it. There's lots of other ways we could have done this, using layers or other things to detect. We also have an explicit reference to that already. So not in this function, but inside of our game controller, we know what the game ball is. And so if we had that reference, what we could do is do private game ball controller. So this object keeps track of the in-play game ball. And so we can actually use that instead. So instead of what we're doing, where we're constantly having to check if the things leaving it are a ball, instead we can just remove that check entirely and use this instead and do a ball controller equals find object of type game that. So we can do something like this. That will get us the reference there. And then instead of this request, we can just say, see if the game object is equal to the ball controllers. What do we call it? That's an important thing. Let's go and check that out. So let's make a public reference to this. So public in play ball. And I'm actually going to keep that private and make a public property. Public game ball question mark. Let's do a game object that returns the game ball. And that's just going to go and find the in play ball.game object. And that way we can just get this. It prevents us from being exposing this property to writes. So if we made this field writable, we could potentially overwrite it, and we really don't want to do that because it will break things. So this prevents that from happening and still allows us to do this. So this controller still owns this object, and everything else can only read from it. And I think that makes sense. We'll see what happens. So we have that. Let's go here, game ball. And now we're just comparing these two game objects and seeing if they're the same reference. And if they are, then we know we have the correct thing. Otherwise, something else has gone through. And I think that should be enough for us to actually detect what's going on. Okay, it doesn't like when I do things in onDestroy. I think there's another way to do that I should check, because otherwise we're going to get that error every single time I stop playing. But if we do that, it respawns, everything works. We correctly detected that it was a ball, but the player doesn't get destroyed. So that check is actually working now. We're not actually destroying our player, which would break the game. We could handle other things with the player. We may want to like force the player to respawn if flying through the goal would put you out of bounds. I don't know yet what makes sense. In the previous version of this game that I built, that was how that worked. It would destroy your ship if you went through the goal. It was like a laser field or something. And that prevented you from just creating like a wall in front of the goal. But we'll see. So there's all of that. Let's do scoring. So we have the scoring zone. This is our goal detector. let's create a teams enum, I think. Game teams? Question mark. I don't know what this is going to be called or how this is going to work. But we're gonna do that and call it team 1, blue team, and red team. I actually don't know the best way to do this. The downside of this is it hard codes the color, which isn't actually that big of a deal. This could just be a default and you could still change them, but it might be more confusing this way rather than team 1 and team 2. Or we could do it based off of the orientation. So like the north team and the south team. Because the game is always going to be oriented in the way where going up goes towards the one goal and going down goes away from the other thing. Rotating the camera just gets you lost, I've found. So in this case, we're going to have like a fixed rotation on the camera. It will move and pivot and follow the player. But we're going to do this instead. And I think that makes sense. Sure. And that way you can at least detect where things are. It also makes the assigning the goals to the correct team very quick, because we know one is the north and one is the south. We can do a detect goal. Yeah. So this is our scoring system. Let's go and add public enum. Oh, that's not right. Public game team. Or teams. I don't know if I like that being plural, but we can assign this to our defending naming is hard, and I don't know if this is the best name for this, but we're going to try this and see how it goes. So there's our defending team. So that'll be the team that's defending this goal. And then if you score on that, it gives the point to the opposite team. So let's create a function for that. So a private void scored goal ? And we can do defending team, or switch actually will work on the defending team, and we can do something like that. And that will give us a way to actually assign different things. This might be more than we actually need for managing this. A switch for just 2 cases is probably too much. But I already wrote it, so we're going to keep it for now. A lot of this is stuff that we can come back and rewrite later. If things start behaving or weirdly or whatever, we can rearrange it. But we need to now manage the team's scores. So this is one of those times, earlier in the stream we were talking about how decision making kind of comes in. In this case, we have this unimplemented score controller, and we need to track scores for different things. There's lots of different ways we could do this. The 2 that I'm thinking of are public int north team score and public int south team score. As well as our, what are we going to call this? Our thing. Sorry, public dictionary of our game teams and an int. This would work too. And this could be our scores. Either of these are probably fine options. That either of them I think would work. The difference is this one limits us to it hard codes the number of teams in the game, which is fine. It's cool if we only have 2 teams. This one makes it possible for us to add any number of teams at any point in the future without breaking anything. The only downside is it means that anytime we want to interact with scoring, that we have to work with the dictionary. I think that's fine though. And it might actually make things a little bit nicer in other ways. So let's try that. So this should be private probably of our scores. And we'll need a way to actually be able to see what score any particular team has, but we won't do that yet. Scores equals a new dictionary like this. And we're going to do the dictionary constructor. So what we've done is done a like list constructor, and then you can do key value pairs as the option here. And so game teams dot north, set that to 0. So the default score is 0. And then we can do this. So we're creating something with both teams equal to 0 points at the start. And then anytime we want to update that, we can just find and update the score for that. So we can create a public method here, I think. Public void score goal question mark for our game teams with the scoring team as an argument. And this will give us a way to actually go and look up in that dictionary which team we need to increment the value for. So we can go and find the game teams and then increment whatever that is. So how this is going to work is we're going to make an assumption here that the key already exists, that we already have the key that we're looking for, and we don't need to check that it exists or not. This isn't something that you can do all the time, but in this case, it should work because we have an exhaustive list here. This will break if we ever add another team, but also this is a prototype and a beta, so we're going to do that. It will just make things go a little bit faster for us. So let's do that. So score goal for the team for our current score is going to be equal to our scores dot, let's go and find the scoring team's current score incremented by 1. So current score plus plus, and then we can do scores dot I'm trying to think if it makes sense for us to try something else, or we'll just do this. So we can remove the scoring teams reference, and then we can add it back in. Oops. Add the scoring team with the current score. And this will actually replace that key. For whatever reason, maybe it's just because we've been streaming, but I can't remember if adding will override or not. We can actually find that pretty quickly, I think. So let's do that. C# dictionary. Now let's just quickly look up what add does. so that I actually know what's going on. Methods, add. All right. So adds a specified key and value to the dictionary. Yeah, so this will throw an argument exception if the same key already exists, which would crash. In that case, bad things would happen. One, you wouldn't score. Unity somewhat handles exceptions, and what that means is if we throw an exception here anywhere in this function, what's going to end up happening is it's going to exit out of that function and continue the game. So we'll get a log message, a logged error that's going to cause problems, but we can actually use it later. The downside with that is if we run into that issue here, your score isn't actually counted. You'll just get an exception instead, and that's not as rewarding. So I think this will work. So we have our start that initializes everything, and then scoring goals will work. And then I think I just want some way to get the current score. And I'm wondering what the most convenient way to do that is. Does this have a... Yeah, let's do a read-only dictionary. I think that might be helpful. So public, that's not where that should go. But we're going to make the scores public for read-only dictionaries. And I'm going to rename this. Scores, we'll lowercase that. There we go. And then we'll just create a public read-only dictionary. So the advantage of doing this is because we're returning a type that is the same as our dictionary, so we don't need to do a type conversion on our dictionary, but the person consuming this is only going to see that it's a read-only dictionary. They're not going to be able to see their ability to like add values into it. And so they can't go and start adding additional things or changing it. They can just read the data. So I think that should be a good way to keep things protected, if that makes sense. And then we'll see if that works. But I think that makes some sense for what we want. And then we have a way to actually track scores, and then things can just look it up by indexing into the dictionary. Yeah, I think that makes sense. We'll see. So yeah, let's try this. So the downside of this is now I don't actually have a way to track scoring, because there is no output here. So let's go and print it out here. Debug.log. That was helpful. So we have our current score here, and this will just print this out. We're doing this because we don't actually have a UI way of actually viewing that the score goes up right now. Because we used a dictionary, there is no inspector for that. So we wouldn't be able to see it, and it's private anyway, so we definitely wouldn't be able to see it. So we need some way of actually knowing that the score is incrementing and we're getting points. So we're going to do this. And then what we're going to do is add another reference here to our private game score controller. like that. And this will give us a way to actually interact with that scoring system. So we have score goal. And now I don't need this switch anymore. I might want to switch these. Or do like this dot. Because score goal increases that team's points. And we only track the defending team. We're gonna swap this. And instead of tracking who's defending the goal, we're gonna track who's offending against that goal and trying to actually score against it, because that way we can just, when somebody does score, we can just increment their score. Nothing actually changes, it just does that instead. Otherwise, some other part of our logic would get more complicated, and it's a team v team game. So I think that we're not actually increasing the complexity here at all. And this way we don't need like a switch statement or anything. It can just be one line. And then inside of here, we can score a goal. Cool. So I think that's everything we need. We can handle scoring. And then we just need some way to manage this a little bit more. So we're handling scoring now. I just need to update these. So this scoring zone is for this north team, and this one's for the south team, which is slightly confusing. They're opposite. But I think that will do everything we need to actually score points. And we'll see that in our debug statements when we start actually playing this. We should actually see points. So the south team just scored 1 point. And now if I go... Oh. Okay. Precision is not easy. There we go. Uh-oh. Okay, so we got a few exceptions. The scoring did work, but where are we trying to access this? So inside of our goal, it looks like we're trying to access our object somewhere. But where? All right, let's figure out what line is this on? Line 12 of our game ball controller. Ah, here. I think we can do a null termination operator here. And so what this is going to do is detect if the left-hand side is null. And if so, it's going to stop. If it isn't null, it's going to keep going. That should prevent us from getting that null reference, because what was happening, I think, is the in-play ball. When we score, that gets destroyed. So this is no longer a thing. So this can be null. This in-play ball can be null. When that happens, if we try to access the game ball, that needs to be null as well, because it doesn't exist. But we were trying to access the game object of a null instance, which really doesn't exist. So this should get us the correct value back, but in a way that doesn't break our game. Let's do that. All right. 1 second. All right, there we go. All right, so what we're doing is scoring. We get points for the correct team. Everything works. Let's add a UI to this. So just some way for us to actually track the score, because we can't see it actually anywhere. So let's do that. Over the course of between today and tomorrow, I'll try to build a ring for this. But let's try to get the rest of this game kind of working. And I think I've left us like an hour and a half-ish to write an AI that can play this game against us. So that it's gonna be a really quick AI, but we're going to try to write that for this. Let's see here. Let's create a UI, I think. Sure. I'm not very good at using Unity's UI, so this might not go great, but we can try it. Let's use TextMesh Pro. So I think TextMesh Pro uses signed distance fields, I'm pretty sure, which, if you're interested, are really cool. The way they're used to render text is actually really clever and neat. Something that might be interesting to like look at. But TextMesh Pro is just a way of doing fancy fonts and better text inside of Unity. So that's what we're going to try to do. And I'm just going to add a score in the top left and top right, I think, just to track this. We're going to go really quick for this, just because it just needs to work. I'm also going to turn on the game view. Inside of the scene view, we get this. It's a screen locked thing, so it's really big and over there. That's not very useful. So we're not going to use that. Instead, we're going to kick this off over to the game view, where we can actually see what things look like. So this will be our South team score and our North team score. We're not going to, the South and North concept is not something that we ever need to show the player. This is just something that we're using as a reference, like a reference in our editor for where the two teams are located in game, and also how they're like scoring and linking that way. In game, we can identify them by colors or something else, and that's probably what we're going to do. I think like red and blue will work just fine. We can just find colors that we like. Sure. That'll work. And then we can just place these probably in the top left and top right of our screen. And so the way to do that, is not doing that. All right, we want to be top left aligned. And then adjust this. There we go. All right, so now we have our text. You can barely see, there's like some red stuff up in the top left. So then we can go and put this in the same position on the right-hand side. Like this. So the position X and Y are offsets from that. And then we have the width and the height. So what I think I want to do is just do, for the one in the top right, we're going to do -half of the width. And then for the other one, just half of the width. That will center that or move it so that their size, the box that bounds them, is fully inside of the screen. And then with the position Y, we can just subtract a certain amount. Let's do just 25, so another half of their value. And that will get them into view at least. It doesn't look good, but it works. And then I'm just going to right align the one in the top right. And then if we want these to look a little bit nicer, we can do like, we can change this a little bit. So like move it over a little bit with like, by adjusting these. And that should hopefully make everything look a little bit nicer. But this way we at least get scores. So the next thing to do is create a new UI. So we're going to create just a series of things for tracking UI stuff. So in this case, we have our show score as text. Sure. That seems like a fine name. And so what this can do is track something. Welcome back. What this is going to do is do a thing. I think it's called text, but it's not that version of text. We're actually looking for something else. There's a text. Text Mesh Pro something. All right, let's go and find it. That, and then we just need to actually get the correct thing, which I never remember. Text Mesh Pro. Yeah, that makes sense because it's inside of Unity's GUI. So I think that's what that UGUI thing is just Unity GUI. And then we can just do our text and then our public game team. And this will be our tracked team. So we can assign this the correct team. And then we'll want a private score controller. Like that, I think. And then inside of the start, we can just find the score controller. So just that. I don't think we need that game object thing. We can just use this. And we actually want this to be a find objects of type. So we're just going to search and find the thing. And then from there, every update. This does not need to happen every update, but we're going to do it every update because we're not going to do it every update. I have a better idea. Let's create an event. Does this make sense? Maybe. Why not? It'll be fun. So let's go and create an event for this. And the reason we're doing this is that this way we can have a callback that triggers when this function ends. So when you call score a goal, it's going to score a goal for the team, and it's going to send a message that says this team's going to score a goal to everybody that's subscribed to it. And that way, you only need to update that UI when somebody scored a goal, because there's only going to be like 4 or 5 goals scored in a game. So we don't need to update this every frame, because then we're updating like 60 times a frame or a second for something that is actually only going to change like a couple times in a few minutes. So I think this makes more sense. I just need to remember how to build events, which I don't remember at all. Is guessing at this a good idea? Nope. But we're gonna do it anyway. Just because I'm curious if I can get this correct. How does this work? Float? Question mark? Test? So I think action will work, but we're trying to get multiple things that can subscribe to this. So an action would allow us to assign one invocation. So one thing that can happen when this happens, or when this is triggered. I actually want something where we can have, in this case, we're gonna have 2 score trackers. that are both going to be looking at this scoring system. We're going to want something that can both react to this. And I think we might even want like our AI to react as well. We can figure that out. We'll be doing AI as soon as I finish this. So let's do C# event, custom events, and we'll see what we can find here. So events. This is where my limited knowledge in this area comes into play, because there's delegates too. And I don't know the difference, so we might take a little detour and figure out the difference. Delegate is a type that represents references to methods with particular parameter lists and return types. So a delegate can store a list of references. That's perfect. That's exactly what I want. So let's create that. Public delegate void game goals scored handler question mark. Okay, want to be really clear here. I don't know what I'm doing. So naming and conventions and everything, this is probably not what you should do, but it might work. So we're going to use this as a way to game team with an int of the score. It suggested it to me. I should have just taken it. And there's our score handle. And then I think we need a public event handler with a goal. And then this can be like on goals scored. And I think this is how this works. It's been, so I used to do this all the time with WPF and some of the UI frameworks and stuff. But I haven't worked with those in a while, at least not in depth. And so I'm not entirely sure anymore what the format for this is. But what this is doing is defining a delegate, which is a function template almost. And then we can use that and receive results from this using that function template. So we need to subscribe to it with things that match this template. And then that event will publish out the team and the score of that team whenever they score. I think that makes sense. Let's see if it works. So what we can do is on goal scored question mark dot. The reason for this is events are null if nobody has subscribed to them, which means you'll get a null reference exception. So you need to check this. And then we can invoke it with this as our sender, and then the new goal scored handler. And we're just going to pass in the new team, which is the scoring team, and the new score, which is the current score. Does this work? Question mark? What have I done? It doesn't like this. With a method name expected? Huh. What method? Have I done this wrong? I'm way off into things that I don't know. And this is only going to save us like a little bit of time. So I could be wrong, but I think the event handler is what allows us to invoke the event. So the event handler is providing the invoke functions that we're using. So event handler C#. If we go and look at what this is doing, it's going to handle that for us. So I think if we look at this somewhere, this might actually give us our answer too. So public event handler for the type that we're doing. So that's not a delegate either. I don't think I need both of those. I think that's what's confusing me. I think I just need this. Yeah, so event handlers, and maybe this is me let's try it. What could go wrong? It's not going to compile if it doesn't work, so we can just try it and see what happens. So goal score handler does this, and we invoke it with both of these. So I guess I don't need the event handler. The event handler might be doing something else. It might be tracking more things, but I think this is correct. I think you might be right. But this is just being completely honest here. This is not something that I actually am very familiar with. So it might work. But what we're going to do is just send that off to things, and then we can respond to it. So here we can grab our score, and then we can subscribe to that by attaching to the event that handles the score, which is somewhere. What do we call it? On goal scored plus equals something. And so this is going to have our team and score. And then if the team is equal to the tracked team, then we want our text dot text. That's just poor naming on my part. Text is the actual text that's getting written. And we just want to write out the score like that. Team, there we go. Okay, everything I've done is angry. Oh, well, that's not going to work. And do these need to be explicitly typed? We're still on that area of me not knowing entirely what I'm doing. But I think something like that. Let's not that. Hold on. That's not what I want. So what we want to do is create a reference to this that is going to do that. I was trying to avoid this by using lambdas. Not sure why. Update score on goal. Sure. So what this is doing is mapping this function to that delegate, and then we can invoke it. We'll just invoke everything in that list of functions that has subscribed to it whenever we intend to run it. Yeah. So what that means is that I can then go and do something. we can go and run our score update that I had already implemented and deleted. That wasn't smart. So team, if that's equal to the tracked team, then we can set our text equal to the score. There we go. So that will actually make sure that everything is working, that we actually have our correct text assigned, and it should automatically update as a push. So our score tracker is then going to push score updates to the UI rather than the UI going and polling every frame for a new score change. That seemed like a lot of work. I don't know if that's any better, but it was fun, so we did it. But there we go. So now I just need to assign both of these two new text fields to the score. And we can do that just by dragging and dropping ? That didn't work. There we go. And we'll assign this to the North team as well. And actually, I'm not going to do that there. I'm going to move these up to a score tracker. Move both of these into that. And this will just make our UI a little bit nicer as it gets more complicated. We can do a score tracker and put both of these there, and then just assign them different values here. Because we're not referencing the thing that's currently attached, we're actually dynamically defining this. I can actually point this in any direction I want. So we have south and north. And I think it should work. So right now there's no initialization function, so it doesn't actually update the new text until I score. But if the callbacks work, we now have 1 point. So I guess it does kind of work. So now we can actually score points by doing all of this. So what I'm going to do now is change directions entirely. Let's write some AI. We're not going to do any machine learning or anything like that. We're going to do some like really quick and basic AI stuff. The cool thing with this is you should be able to come in and write your own if you want. Eventually this will end up on GitHub somewhere. So you would be able to actually look at this project, and if you wanted to, figure out where I put the AI, which is probably going to be inside of here somewhere. And then add your own. We might have time to write more than one, but I don't think so. And this field might be too small. Actually, let's make this bigger before I do all of that. So let's make the game field a little bit more realistic. Let's do like 50. Is that big enough? 80? I'm just guessing here, just trying to get something that'll feel big enough for you to actually play, so it doesn't feel like everybody's just crunched into a corner or into a really tiny box, but also big enough to like play in. So let's change this. Let's move these all up. Minus that. Sure. And then let's put these up at the top. And again, eventually, once we get past the point of actually figuring out what feels good, what is fun to play, then we can go and actually swap this out with real art that actually fits that. But we don't know yet. So for now, we're just experimenting and trying things out. So this is just that. It's just an experiment. And let's do 15 and 10. Okay, that's a very large goal. Oh, that's gone the wrong way. So all I'm doing is just trying to tweak this to get it to something that feels right. It doesn't even need to align perfectly. So that'll probably be fine. Something like that. And then we can just mirror that down at the bottom. Cool. All right. So now we have a much larger field. We can no longer see the edges. We do need to move our goals to like 39.55, something like that, and scale them up to like 2. So negative 39 and twice as wide. All right. It's a little bit less easy to see everything. This is why I started as such a small thing. By keeping things small to begin with, we could test things, make sure it worked. Now, I think I want, before we do AI, let's do a camera controller. So I can actually move and the camera will track me. Yeah. This can go in the ship. Can it go in the ship? We'll see. It's gonna go there for now. This will be our overhead camera tracker. So one of the useful things of how we're doing this is a 1-player game. So we know who the player is and we can track them. This would get more complicated if it was like a multiplayer thing. That's something that maybe we can expand into, but I don't actually know anything about writing multiplayer games. And that would be a very significant amount of time. So we definitely aren't going to get into that this week. If that's something you want to see though, let me know in one of the chats or send me a comment later and just say you want to. And I can try to find some way to do that. But for now, we need a way to track our player. And we're going to do that by tracking the rigid body. Tracked player. And so let's also do a public float lift. I don't know anything about cameras, so we're guessing again. But we're gonna guess like 10? Sure. That seems like a fine number. And that's just going to be the amount of height we're adding above the playing field. So how high we want to move our camera up from the current player. So if it was 0, it'd be inside the player, and then 10 is just zooming out 10 units. And then we're going to track the rigid body because I actually want to take into account the velocity of the player. So if you're moving forward really fast, being able to see what's behind you is less important than being able to see immediately, like further in front of you. So if you have a high velocity going forward, I actually want to move that forward a bit more. And I don't know how we're going to do that. we'll figure that out in just a bit. Actually, public float vector 2, vector 3. Guessing again. We're going to do a camera offset. And this is going to be how far off of the player we're actually going to track things. So if we do a tracked player, there we go. Let's type this correctly. We can do a get component with the rigid body 2D, like so. And that will actually give us a way to track all of this. And then we can use that. So set the camera offset equal to the tracked player's velocity, the vector 2, which is fine actually. So let's just make that a vector 2. We're working in 2D space, so that should be fine. Velocity. There we go. And so what this is going to do is just give us a way to track that. I'm turning this into a state because what I want to happen is as the player moves, I want to adjust this relatively quickly towards the new velocity, but I don't want it to be instant. And the reason I don't want it to be instant is because if you hit a wall or something, it's just going to immediately go to 0. And that means your camera is going to jump. And so by maintaining it as a state and doing that, we'll get a little bit of a smoothing effect. So our camera will feel like it's more on a spring than it's just attached to that velocity. And so we can use that to kind of tweak things and hopefully get a nicer camera feel. I hope. And we can add a value here for like public float camera springy. I don't know how to spell this word. I will just set that equal to something. This is going to be a multiplier, so we'll figure it out. But then in the update, we can do our camera, or this rather. We're going to just solve for the new position of the camera is what we're doing. So we have this. Position, I guess. We're going to do a tracked player dot transform dot position, get the current position of the player. And then what we're going to do is add a bunch of stuff to make this work. So we're going to solve for the camera offset by taking the camera offset and setting this equal to a vector3.lerp. So if you're coming into game development and you aren't familiar, a lerp stands for linear interpolation. So what we're doing is we're taking two different things. This could be floating point values, or this could be vectors. And we're linearly interpolating between them. So drawing a line between them and then picking a point between there based off of a value we set. So what we're doing here is giving it our current camera offset and then the new target position that we want, which is going to be equal to the tracked player dot velocity. We might want to swap these around. We'll see how this feels. I rewrite this every time I try to do games, and I do it differently every single time. So I don't know if this one's gonna be good, but this is sort of something that you kind of I like to play around with because it depends on the type of game, how the camera works. But I think something that gives you a little bit of that velocity padding should be useful. And we might want to add a scalar onto that as well. Public float camera extension ? Don't know what that's going to actually mean, but we'll just plug that in there. And in here, where we're already using it. And then the third argument in a lerp is going to be your factor. So I mentioned we're interpolating between the current camera offset and the target new one. So we need to figure out what that is. In this case, it's going to be like time.delta time times the springiness. and then it will clamp at 0 and 1. So if it goes below 0, that shouldn't happen. And if it goes above 1, it should just take the value for 1. It shouldn't continue interpolating the vectors and like get a point that continues the line that would exist between two vectors. That shouldn't happen. So there's our camera offset, and we'll solve for that every frame. So the camera will slowly move based off of how we're actually flying, but this should give us a little bit of like view in front of us. So as you move faster, you'll be able to see more and more in front of your player. And I think that makes sense. We can tweak this so that your player doesn't like go off screen or something, because that would be less useful. But that's sort of how this is designed, I think. So let's see here. We have our position. We have our camera offset. We want to take our position dot x plus the camera offset dot x plus equals. There we go. And do the same for y, and that will affect both of these. And then we also want to lift the camera off using this lift value, and that will do this. So position dot z plus equals the lift. And so that should hopefully give us a working camera. This lift may need to be inverted. We may go through the thing, so if we don't see anything anymore, that's probably what happened. But this hopefully gives us a nice camera that will follow our player with a little bit of extra padding, so we can see a little bit better. Let's go and add that to our ship. Actually, to our main camera. There we go. And then we can just directly plug in our ship with all of that. And then hopefully we can just play this and see what happens. And hopefully it works. It definitely did not. Right. We're assigning this manually, the tracked player manually. We do not need to assign it inside of start. It was looking for a rigid body attached to the camera, which there isn't a rigid body attached to the camera. So this should fix that a little bit. What? Oh, you're probably right. We changed a position value that isn't actually perfect. That's probably going to help a whole bunch. So hopefully this makes a lot more sense now that it actually works. And we went the wrong way. So we can test this really quick. We don't even need to restart our game. We can actually just change this value in the editor and just do -10. And then if we start flying, you can see the camera kind of moves and in front of the camera or in front of the player. So like this. And hopefully that's more useful. And then as we stop, it kind of recenters on the player again. And so I think that'll be a little bit nicer. But yeah, that's how that works. We also get like some really cool like feedback now when we actually collide with things, because the camera actually bounces back because we get a negative velocity. So, but yeah, that's all of that. Hopefully it gives you a little bit of a view into like the play field now, so you can actually see what's happening. What else should we add? Now that the ball can go off the screen, we should add something that points to the ball. I'm thinking of things to do. I'm just getting all of this stuff out of the way before we do AI stuff, because I think that'll be a fun way to kind of like end this up. We have about an hour left in this stream, and then we can pick this up tomorrow, and hopefully tomorrow we're mostly done with the game already. Once we get AI in it, at least the core bits all work, and then we can start adding cloud components to this. We can start adding playfab and things like that, so that you can log in and actually like customize your ship, and have it persist between playing, even if you like uninstall and reinstall or bring it to a different device. It would keep all the same settings, and your like high scores and total goals scored and things like that would all persist. That's what we're going to be adding over the next 2 days. But yeah, let's see here. I think we just need something that points to the goal. So how do I want to do this? We could put a ring that points somewhere around the ball. Maybe that's less interesting than doing the AI. Let's just do the AI. Just thinking that it'll be more interesting to do that than it will be to do everything else. We should also rename this prefab to the player ship, because the AI ships are going to be slightly different. And so we don't want those prefabs to get confused. So this will be our player ship. And then we're going to create a copy called our AI ship with nothing there. The only thing we're going to do is we're going to remove the player input controller. So what that player input controller is doing is handling input from the player. So things like keyboards and controllers, which are both great question. I've never used a prefab variant. Let's try that. So most of what I've been doing with Unity lately has been editor tools and things like that. So there are some things that I know slightly less about. But this will be our AI ship. And so I think by using a variant here, we'll maintain the link between the two prefabs, just with differences. So in this case, it doesn't have a player input controller, and it will have an AI controller, which we're going to create now. Basic AI controller. This probably isn't going to have lots of smarts to it. I don't know if we have that kind of time, but it is going to at least like track the ball, and that's about it. Can it track? Yeah, that'll make sense. Private void ball controller. There we go. So we're going to track the ball state, and use that to actually figure out where things are. And then we're also going to go and find private goal. And we call this detect goal, but that's really the like goal controller. It manages scoring and things like that. So we're going to attach to that and figure out teams or defended goal and the private target goal. And we'll need to figure all this stuff out later. And then this will give us a way to figure out what the ball is and figure out where your goal and where the target goal is. And I think also probably detect things like if it's on your side or whatever. I'm going to try to make this just work. So the intent is that it's going to try to angle itself So it is creating a vector where the ball, and the target goal are all in a line, where it is on one side of the ball and the target goal is on the other side, so it can push the ball into the goal. That is the entire plan. And we're just going to try to figure out how to make that fly to do that. We only have turning and velocity as our inputs, so that's the only thing that this can do. And then we can do like more useful versions of this later that might like try to actually defend your own goal. But this defended goal, there we go, is going to manage that. So there's our ball state controller. Let's go and find that. Find object of type. There we go. And we should be able to keep a reference to this constantly. This is a global thing, so as long as the scene is loaded, we should be able to see it. Then the other two things we need are the goals, which we can do by just finding the goal. We do need to know what team we're on though. So public game teams team. And then all we're going to do is say var goals equals find objects of type. So there's a variant of this that will just find every object of the type, which is even slower, but it's fine. We're doing this at the start of the game, so it should be fine. It will just be slightly slower, but we don't have that many game objects, so it's not that big of a deal. So we're getting both goals, and then for each var goal, in our goals, if the goal dot offensive team is equal to team, then the target goal equals that goal. Otherwise, the defended goal equals the goal. I think that'll work, because we should get two goals. If our target is equal to that, that's the one we want to score in. So pick that one. Otherwise, use this. And that should be everything we need for that. This isn't going to actually do anything yet, but it'll at least let us get started. So let's go and assign this to this. Oh, okay. I can't move that. So we're part of the North team. So our player is on the South team, I guess. We don't really have one assigned, but we can move this AI ship up like that, I guess. And so we should see the ship is facing in the wrong direction. It's facing up. We'll need it to turn to actually face this, because there's no like sliding. It can't slide in space, can't go left and right. It can only go up and down. So we always want to make sure its front is facing where it needs to. So how is this going to work? I think what we can do is use dot products for this. We've already used them before. Remember, dot products are cosines, they're angles between two 3D vectors. We can use that to figure out if a ball is in front or behind or to the left or right of the player. So I think that's what we're going to do. So let's first, we actually need to detect the ship input. So private ship input. This is how we actually are going to tell the ship what to do. So we actually need a reference to that input. So get component of ship ship input, and that just is this. It doesn't even need these functions. It just has forward and turn. And so turn is, I believe, a clockwise rotation to do its thing. And so you just, 1 is equal to turn right, -1 is turn left, forward is go straight ahead, and -1 is go backwards. That's the entire control scheme. So we just need to write functions that solve for both of those. So we need to write a function that returns something for forward and something that returns a function for backwards. What functions? So I think turn is actually not too hard because we can do, well, first, I think what we want to do is solve for a target point. So right now we're assuming that the target point is like the ball, but that isn't actually true. We'll have different target points depending on what's going on. So get target point. So what I'm thinking is, if we've scored, if the ball doesn't exist, go back to your goal. So everything will just kind of clump back to the goal, just so that, like, you have some defense. Because otherwise you might, if they were trying to score, they would all be on your side of the field, which then how do you defend that? So we can get the target point that will figure out if the ball exists or not. So if ball state controller dot game ball question mark. Is there a better way to do this? Did I create a better way to do this? Is ball in play? That sounds like a great option. Let's use that. So is ball in play? And we do need to still check this, that the game ball is not null, just because it could be that shouldn't ever happen, but it could happen. So this is just making sure. But in this case, the ball does exist. So just for making this quick, we're going to, let's work with vector 2s. There's no reason we shouldn't work with vector 2s. We're in a 3D space, but vector 2s will be X and Y, which it's a 2D game, which will make our math easier. So we can work with vector 2s, and I think that'll make things just a little bit quicker. So is the ball in play? And if so, return a new vector 2 of the ball state.gameball.x. All right, that's a very long function. Let's go and shorten this a little bit. Var target, set it equal to that, and then we can just shorten this, so target.x and target.y. Just saving us a lot of extra writing. And then we have our target, and we're not even considering like where the ball is. We're just saying there's a ball, run at it. And then we could actually figure out tactics later. But all this is doing is just giving us picking a point and saying fly to that point. So we'll know this is working if things actually do that. So otherwise, if one doesn't exist, then return a new vector 2 of the defended goal dot transform dot position dot x position dot y. Okay, this is getting slightly longer than I wanted. Let's do another target and try to make this a little bit nicer. And just so things don't wait inside the goal, I'm actually going to subtract the up vector. So the up is into the goal. So if we subtract the up vector, we're actually into the playing field directly in front of the goal. So we can actually take target minus equal the defended goal, transform dot up, and just move a bit in. And this is not precise at all. There's no reason for picking this. We're just doing it because I picked numbers. And then we can tweak that later. But that'll just hopefully aim towards the point in space right above your goal. And then that should return it. We just need to swap this out for target here. And that gets us our target point. So now that we have a target point, we just need to figure out how, based off of our current position and direction, our rotation in space, how do we get there? So we can figure out the turning. I mentioned earlier when we were talking about dot products, if you compare two normalized vectors, the dot product of them is going to be 1 if they're parallel. It's going to be -1 if they're perpendicular, or not if they're in the opposite direction, so parallel but passing each other. If they're perpendicular, it's going to be 0. So what we can do is compare, for example, the right vector of our ship to the target point and see what the result is. So we're going to find a delta to target, question mark. And this is going to be equal to our target minus our current position. I might get this backwards. If I do, we'll fly away from our target always instead of towards. But I think we should be good. Can I do it? I can do a cast. Thought so. So I think that should work. We'll see. I don't think I've ever tried this before, but it might work. And so that'll get us the difference between where we are and where we're trying to get, pointing towards where we're trying to go. So delta to target dot normalize is going to get us a 1 unit length vector towards that point. And then we can use that plus our right angle to figure out how we should turn. So just void void on draw gizmos. I'm just going to add this quick so that I can debug this a little bit easier and figure out what's actually going on. Yeah. So let's do a gizmos dot color equals color dot orange. Is that a thing? Nope. Green? Sure. And then we'll do a line between dot draw line between the position, so our current position, so this dot transform dot position, and the get target point. And I think that'll work. That seems to think it can just convert that to a vector 3, so we're going to pretend like that's okay. And that will give us the target point. And then I'm also going to switch the color just so it's easier to tell what's going on. And let's make this red, question mark. Gizmos draw line, or draw ray actually, I think, at our current position with a up vector, so we actually know which direction we're facing. So this dot transform dot up ray. There we go. And so this should give us a little bit of extra information about where we're going and why. And so we can use that to kind of debug what's going on here, because this is probably going to get confusing. And I don't exactly know how. So hopefully this will help us out a little bit. But we have our delta to target. So what I'm going to do is, before doing any movement, we're just going to adjust the turning. And what I want to happen is I want our ships to turn directly towards their target and nothing else. So what we should see is we should see a green line with a red line on top of it eventually. And that would mean that this worked. Delta to target is equal to that. Var right question mark transform dot right. So this is the right side of our ship, and make that a vector 2, and then we can do input dot turn and set that equal to vector 2 dot dot between our right vector is already normalized and the delta to target is normalized as well. So we just need to get a ratio between these. And so let's talk a little bit about how this works. So what I've done is I've found 2 points in space, and then I've said, figure out the distance between those. So I have our ship and the target, and I have a vector to them. And then I have another vector somewhere representing the current right angle of our ship. And I want to rotate this so that if the value is, remember with dot products, if the normalized vectors are perpendicular, they will be equal to 0. So that value will be equal to 0. So what we can do with that is say, if they're perpendicular, that's perfect because we're in line with our target. And so that's why we're doing this, is we're doing this as a way to kind of adjust and turn our ship to face whatever target we have. So there's our input. I think that might be everything. We'll see what happens, but I'm going to add more of these in a few different places, just so that I can see what happens. And I'm also going to open up both of these, and we'll see what happens. Okay, so they're all going back to their goal. And you can see all the red swiveled to align with the ball. Sorry. So if I actually grab this ball and move it, we should see these kind of pivot to rotate towards it. Does that make sense? And so now we have sort of these things that are always going to track it. The only downside is that ship that was directly in line with it also had a turn of 0 because it was perpendicular, but it was behind. There might be a way to fix that. I'm not going to, because somebody else is going to hit the ball and it will fix itself. So yeah. But that's how we do turning, and then we just need things to actually fly towards the target. So let's do that next. And in this case, we can have input, or rather var forward. I'm going to regret naming it that, I think, because we're actually gonna cast the up vector into forward. Input dot forward. Okay, this is, naming is not great right now. But we can do the delta to target and our forward vector, and that will tell us if we need to apply positive or negative thrust. What did I broke something in a way that I don't understand yet. Oh, There we go. Forgot an equal sign. Okay, so I think that should be our basic AI. They're all going to just like clump. So there's not going to be any strategy here. But you can see they're all going back to their thing, and they all turn around. And then now they're going to just, in this case, they're not even trying to score. They're just going to push this probably into a corner somewhere. Oh, they might actually score. Cool. That was convenient. So that happens, and then they'll reset. The ball's back already. So now they're going to score on themselves. But there's that. Our game is probably a little bit too big for the size and speed of all of the ships. We might want to tweak that. But for now, I'm going to leave it. It's kind of interesting. So now we just need this to be a lot smarter. So I think what we're going to try to do is offset this. And this isn't science, I guess. But what we're going to do is we're going to take, when we're targeting the ball, we want this to ideally push into the goal. So what we're going to try to do is figure out a point on the opposite side of the ball to target instead of just the center of that. And hopefully that works. There's probably other smart things to do, but we're not trying to write like the best AI here. We're just trying to make it fun. There's our target for the ball, and we just use the current positions. What I want to do is add something for the target goal. So var goal difference. So we're going to find the target goal minus the ball state controller dot game ball dot transform dot position. That's a long thing. That will get us a difference between these two targets. Is that what I called this? Yeah. So target goal dot transform dot position. All right. Even longer. And so that's the difference between where the ball is and where the target goal is. We can subtract that from the current ball position. So we can do goal difference dot normalize, and that will normalize our vector for us. Let's make this follow our naming convention. And so we get this goal difference here with a vector towards the goal. But we don't want our ships to hit toward on the side of the goal. We want them to hit on the opposite side. So we can do our target minus the goal difference. And I think that should work. We'll see. But then they'll go back there, and then you can see that point should sort of orbit to the other side, and then they're actually not even hitting the ball because I moved it too far back. That's okay. We're going to make the ball bigger. So by some amount, let's do that, and we'll see what happens. This isn't a science. This is just tweaking things to make it work. But also it being bigger means it's more interesting because that looks way cooler than everything else. But you can see the green point is actually inside, but away from the goal. And that's what we want, because that's where we want them to aim. The only downside is that they have now gotten stuck. Let's just do that. Whoa, I did the wrong thing. Select that, and there we go. Okay, yeah, they seemed very smart. They scored on themselves again. That doesn't seem good. Okay. I don't exactly know the best way to fix this. I do know I want things to move faster. So we're going to do that now, I think, by doubling all of this stuff. So what could go wrong? Let's apply all of that. And actually, let's move all of these down to the bottom here, and we can actually just create a game, I think. So playership also should have its stats doubled. And let's go and apply that. And why? Oh, okay, got it. So some of these, when I applied the prefab, they assigned the attached component, which they already had one attached, so it duplicated it. So I'm just removing that duplicate. Let's now actually build the game. Let's do like -10 and +10. And we'll put these at -30. And we can hopefully do all of that. So all right, got distracted, sorry. Where did, oh, okay. -30, and then we'll have the player in the center there, but then we can also have the other 3 AI ships at like 10, 30. And we need to rotate them so that this actually works into the, yeah, no, that's fine. And I'm just going to delete that and just copy this one 2 more times. There we go. And we have our player ship at -30. With these 2, what we need to do is actually change their team to be on the other team. This means that they're actually should now play against themselves, I hope. Just to make this a little bit easier for us to actually see what's going on, we're also going to change this a little bit. Let's go into ships, add both of these to the ships, and add a set of materials. Create one for the north team and one for the south team. So the north team color materials and the south team color materials. And then we can actually just color that equal to the colors that we assign the score, which I forget. So we're going to guess something like that. And then I can actually just drag these on. And we should hopefully be able to track things. We're going to get rid of the cubes really soon. But this at least gets it plain, and we can use the gizmos that we've created to kind of track this up to this point. So it gives us a nice way to kind of make sure everything is working. So we should be able to run this. I send the wrong thing. We want the red team. Here we go. Okay. And now we have everything playing. This is probably going to get stuck eventually, but you can see the red and the blue are actually aiming for different points on the ball to try to score, hopefully. And it's kind of a thing. And then eventually the player can actually jump in and play the game. Why isn't this one moving? Oh, they have a player input. Well, that's not right. Oh, they have what? We're just gonna get rid of that. Oh, they all do. What have I done? This might not be correct. I'm a little confused, but it's okay. There's that. Let's delete everything. So let's remove all of that from the AI ship and apply it. And okay, they no longer have a player input controller. I think we're good. So I can run this again. And hopefully it actually works this time. Okay, there's no balls, so they all go back to their goals. And then rush and try to beat the thing. Okay. This is actually a lot further than I thought we were going to get done today. So that's awesome. Now what? The downside with this is right now the only thing you can do is like headbutt, which I guess works, but I feel like we want something more dynamic. I'll leave that open to chat. If you have suggestions on features or some other ability that we could add to make this a little bit more interesting than that, where everything's just kind of running into itself, that'd be kind of neat, because I'm not entirely sure. Oh, that's why I couldn't see anything. One sec. Lift -10. Perfect. All right. But yeah, if there's some way we can make this more dynamic, that would be something that would be kind of fun. All right. We need to zoom out a little bit. Just so, because right now we move too fast, we actually fly off the screen. So what I'd like to do is do something like this, so we can actually. Oh, the camera might be a little bit too springy. It's kind of hard to aim. But yeah, so this is what we've built. That's a little bit too much, too little? I wonder if I quadruple that, does it get better or worse? And this will give us a nice way to kind of figure out. Oh, it's kind of like jumping around now. Too much. Let's reduce this. And mostly all we're doing here is just trying to tune this just to make it feel nice. Because right now it doesn't really. It just looks cool. Oh, that's a weird effect. Okay. There might need to be some rethinking going on with that, but we can tinker with it later. I like how they run into each other. All right. And I don't know which way's forward. There we go. All right. So we should hopefully end up with less of this tomorrow. I'm trying to figure out what we should finish. Another issue is this. There's a stalemate here. This would be another reason why we might want a separate mechanic. Ideally, this will be rounded off. So we'll create a custom playing area, and this will be rounded. So that'll be less of an issue. But we should still consider that, because that's a problem. Because now the game is just stuck. And there's no way for us to like unstick it. So something for us to like think about, I guess. Because yeah, that's just that. So I think that's that. Let's add a pointer to figure out where the ball is and actually point towards it, so that we can actually find our way around, because it's really hard right now. If I start this, we see this. Where's the ball? I don't know. So let's solve that by, I think, what's the best way to do this? I think we want a separate object that is doing a ball direction tracker. Something like that. And let's just throw this at position 0 and give it a canvas, I think. This is me guessing. I think is the best word for it. So we're gonna just try to figure this out and give it something. We're also going to move this into world space. The event camera doesn't matter. We're not going to use one. And then we're going to center this with like 1 width and height, 2, sure. And then we can use this to point towards the ball, wherever that is. And then we just need to put something in this. So something up will eventually need to go in here. We could use something like a, I don't even know, like a sprite or something, that like a 2D sprite. I almost wonder if something 3D would be interesting, because then we could have lights. Because eventually I'm hoping that we can find some nice space assets that are like spaceships and things that will work for this. That would be cool. Let's go and just try to throw in I guess some text, question mark? Okay, that's way too big. So let's recreate that and give it a greater than sign, which is way over there. Great. Let's go and do that and center it. So now we have this big arrow right in the center. And we're going to shrink this down by quite a bit. That's almost, that seems fine. So something like this, and then we just need to rotate it so that it actually faces in the correct direction. So up. And oh, that's too much. All right, so what I'm trying to do here is just create this arrow here. This will go underneath our player ship, and then we can rotate this entire tracker, sort of like a compass, to always point towards the ball. And that will give us a nice directional indicator of where the ball is. It'll probably look better if I turn on a solid color and actually have this look like that. We should also change the light direction, I think. We'll do that later. But here's our ball direction tracker. We're going to go and add this to ships, I guess. And then go into UI and go and create a ball direction tracker. And then we just need to implement something that is going to point towards a thing. Point towards something that is in our scene. So if we go and create a public game ball controller. There's that. And we can go and fetch that. Something like that. And that will let us actually fetch the ball controller that we're actually looking for. I'm also wondering, I'm going to keep a reference to the text as well. The reason for this is I actually want to fade this out if you get too close. So as you get really close to whatever you're looking for, in this case, the ball that we're trying to track, I want to actually fade out the text indicator so that it's less obvious, because it doesn't need to be there if it's on screen. So we can actually just fade it out and get rid of it. Which I think we need some more Text Mesh Pro stuff. Text something. We already used the correct thing. So Text Mesh Pro UGUI. And we'll probably just assign that. And then target is going to be the target thing that we're actually locked onto. So let's call this the origin instead. So we're going to actually, this dot transform dot position is actually going to equal the origin dot position. And this dot transform dot parent is going to equal the origin. So this is going to do is move it to wherever the thing is and lock it to that position. It's going to actually parent it inside the hierarchy of Unity. So we can actually keep it assigned to that. Means all the rotations and stuff will all follow it and track it, and should give us a nice way to make sure all of that works, I hope. And so then all we need to do is do dot rotation dot point or look at rather. And that'll be this dot transform dot up. And we're looking, the forward vector is that, and we want this dot transform dot forward, which is into the screen, to be the up vector of what we're actually doing. So this can be a constant. We need to change this transform dot up to be something else. In this case, we actually want it to be equal to what? The difference, I think, between var target equals the ball controller dot game ball dot transform dot position. So we're going to look up the position of where our game ball is, find that as our target, and subtract our current position, and that will get us a vector towards the ball. So we can do that. And then we have all of this. So there's our target. We're going to swap that out for our up rotation. And this probably isn't going to work because I don't think I've thought this through entirely. But that will get us a rotation that we can actually look towards where we want to go. And should hopefully give us a nice tracker. And then we can work on fading it out later, because now that we have that vector, we can actually use it for all of that as well. This won't work because we actually need to make sure that the ball is in play. So if ball controller dot is ball in play, dot game ball is not null. So this is just confirming that things are in play and able to be targeted, and that we are able to actually look at what we're trying to do and use that. So if that's true, we're good. Otherwise, nothing for now. Nothing for now. We're just gonna leave it. We might change that later. We'll see. So if we go and run this, I didn't assign it at all. That's not going to work. And we just have a static thing. And this is, oh, that's not good. AI controller at 46 is throwing a null reference exception. Uh-oh. Did I do something weird? I don't think that should break. So we're gonna run this again and see. Yeah, okay. I must have like restarted this while it was doing its thing. Everything crashed. And then when we stop, we throw a whole bunch of exceptions. I'm not entirely sure why. And we're still throwing exceptions. I'll need to investigate this after we finish this up. But that's that. So now that we have this ball tracker, let's go and assign this so that it can actually work. We can actually use it by attaching it to this goal ball. Where did I put it? Here it is. All right. So we can find our player ship, and that's the thing we want to actually track. the ball controller will automatically get assigned, and then our text is here. So hopefully that's everything we need for actually tracking this. And then it respawns. All right. Let's pause this for a bit. Well, that's not right. I think what I want to rotate this so it's in line with our Z axis, which is rotating along the X axis. So we're rotating things forward, so that the arrow is now pointing into the forward vector. I think that should fix this. What we should also do is, instead of using transform.up, we should use a static thing. So vector3 dot back, which is the opposite of forward. So forward would be into the screen, back is going to be back towards the camera. We want that to be the up of what we're doing. So that way we're always showing the correct face of our rotation back to the player. I think that should fix it. Yeah. Okay, there we go. It's a little flickery. I don't know what's causing that. And it's rotating. Which it shouldn't be. Oh no. Let's solve this a different way. I don't think we need to make this as complicated as I did. I can actually use an Euler rotation for this. So instead of that, we'll rotate so we're back facing up. And then what I want to do is rotate it along the Z axis. So I want a Z rotation that matches the arctan of the difference. I think that makes sense. Think I remember trigonometry. So let's try this and see what happens. So we have our direction tracker, which is here. And instead of this, we want quaternion.Euler. Rotation, I think, is the correct one, with no X and no Y. Again, 2D, so we want to rotate along the Z axis only. And we want this to be, I should normalize this. Target.normalize. There we go. And I want this to be a atan. Math F atan 2 of Y. So target.y over target.x. I used the wrong one. All right. And then this returns radians, so we don't want that. So let's do a rad to degree. So rotations are measured in degrees, so we're just converting that. This is just a constant value, 57.29578, that converts from radians to degrees for you, if you multiply that inside of your formula. And I think that should give us a correct angle to actually point towards where we need to point, by using trigonometry, or it'll point 90 degrees in the wrong direction, which we can fix by subtracting 90. Because that's probably the best way to solve that. Yeah, I don't know why that's That's making me think that my formula is wrong in some way. So I may need to tweak this. But now it should constantly point towards the direction of the ball. And it will be less finicky than some of the 3D options we had. So I think I prefer this. It gives us a nice little indicator without being too obtrusive. And now all we need to do is actually make this fade in and out, depending on what's happening. So let's do that. Text dot color equals color dot lerp question mark. And we're going to look from our current color to the target color, which we don't have yet. By some time delta. I don't think I want to do this. We'll talk a little bit about why in just a second. But what this is doing is actually interpolating between our colors in like a smooth way. What I would like to do is have color dot transparent, whatever that is, clear. So the downside with clear is it's actually 0, 0, 0, 0, which means if we actually lerp between those two things, what's actually going to happen is we're actually going to fade into like a gray as we go out to from white. So I want to stay white with the colors and just fade from white with no transparency to white with transparency. But what we're going to do is save off this magnitude. Like this. Color target equals 0. I think that'll work. I would say what I was trying to do, but I don't quite know yet. So before I normalize this, what I want to do is save the magnitude to the color target that we have. Is color space linear? It depends. I believe inside of here, if we go to the project settings, there is a graphics setting, which is somewhere in here. I don't quite know off the top of my head, but there's a way to switch between gamma and linear color spaces. If you're unfamiliar with what that means, so a gamma or a linear color space means that colors move linearly. A gamma actually uses a ramp. And what that means is that you get more definition in like the blacks of your game. And there's less like weird coloration and artifacting in darker spaces. That's what's going on there. I thought it was in here somewhere, but I don't see it. It might be in your camera. Let's see here. Perspective, rendering path. I don't see it here either. All right, now I'm intrigued. It's definitely there. I just don't quite know where to go. There it is. So if you go into player, there's a setting here for color space. The default is usually going to be gamma, but you can switch it to linear and it will ask if you really want to do that. That's how that works. So yeah. As far as you working with it, the color lerps and things like that, you do not need to worry too much about that. It will just slightly change how things are actually rendered. You could factor that in, I guess. But I never have when I'm working with it. That's just me. Most of my experience is like personal indie games, usually very small things. So it's not something that I've really invested in. All right. So what am I doing? We're trying to solve for a target color. We might not even have time for that. We have like 3 minutes left before I'm supposed to end this. So let's quickly try to solve this. We have our magnitude with a color target. Otherwise, if the ball doesn't exist, the color target is 0. And what we're going to do is actually divide the color target by 5. And I'm just doing this divided by equals 8. Let's do 8. All this is doing is shrinking that. So we have a linear length between one point and the other point, which is the ball that we are tracking. I'm shrinking that down between 0 and 8. And then what I'm going to do is assign this. So color target equals color, or equals rather float math, there we go, that clamp between 0 and 1 of the color target. There we go. That's just going to make it so that that value cannot exceed 0 or cannot be below 0 or above 1. So now any value between 0 and 8 gets shrunk down between 0 and 1, which means when things get below 8 units away, we're actually going to get some transparency, and then we can use that to in this lerp function to do a color dot white or versus color dot transparent, but I need to swap these. So color dot clear is there, and then this, instead of the time, we're actually just going to use the color target like this, and that will actually should fade things out as we get really close, I hope. The only downside with this is that there is no negative. We could add that in using the same sort of thing, which we can do right after this actually works. So as I get close, you can see it starts fading away like that. And it kind of fades out as we get really close because it's no longer needed. What we can do is actually shift this too. So we can actually just move this, so color target minus equals 4. I'm just guessing at numbers here, and we can actually kind of tweak that. If you're interested in color spaces, I'm not actually sure if I know any good places to recommend. I really enjoyed when I started kind of tinkering with things. I really enjoyed getting into shaders and things like that. You can even write custom shaders for like your terminal. So like this is just a custom shader that I wrote that was drawing a flag. You can go and do that. There's lots of really fun references and ways to learn from that. Otherwise, I don't really know. The graphics side of things is fun to tinker with, but I'm not super good at it. So anyway, by shifting this by 4, if we're less than 4 units in, it should cause this to be a transparent color. So it should just go fully transparent. So as we get really close, you can see it's just completely gone now. So we have something that's a little bit nicer. But yeah, I think we actually accomplished quite a bit today. So I'm going to wind down and end the stream. I hope all of you had a great day. We will be back here tomorrow at the same time, so 11 to 3 p.m. Pacific, doing more of this project. So probably going to be either finishing this up a little bit and then adding in PlayFab and a few other online bits, so we can actually start making this more interactive. That's sort of where I would like to go. We also need things like a main menu and things like that. But yeah, that's sort of where we are right now. I will also try to get this on GitHub and try to find some art that we can use that would work inside of this project. If you do like this kind of thing that's longer, more project focused, let me know, and I can definitely try to get more of these worked out. But other than that, I think that's mostly it. So thank you everybody for watching, and I will hopefully see you all tomorrow. Actually, tomorrow. That's the day. So anyway, yeah, thanks everyone, and I hope you have a great rest of your day. So thanks. Bye.